Oh, am I muted? Uh-oh. Sorry about the pop. I'm gonna boot up the fan. I have to like ease it into operation. Otherwise it'll make a ton of noise under the PWM that I've got. Boy, wouldn't it be something to put like a 3-phase motor in this fan so I could run it without it vibrating so much? It really is vibrating a lot. Then I could have a legitimate speed control on it. Why don't they do that? I guess it's too expensive. Like even Dyson uses a universal AC motor, but they've got like special magic. They've got very nice motors. Hey, Keeper of Maps! Subscribed to Tier 1 for 35 months. And on a streak. Hi, Bubby. I know, I'm making a lot of noise. What am I doing? What's going on over here, Bubby? What? Oh, you're just gonna peek? Peek from around me? Yeah, I moved your bed. I moved your bed. This is my pile of things that smell like oh bother that she likes to hang out at. What you doing, Bubbo? You good girl? Oh, looks like she's trying to settle down. I guess at the breeder, they would have like blankets and stuff on like a concrete floor, and that's what the dogs would settle down with. So she's doing her little ritual of harassing my linens, and then she'll probably lie down in them. Look at this little puppy. She mad cute for real? Yeah, for real though. Look at this little puppy. Willa doesn't know what a camera is. She doesn't know that she's on camera, so she won't look at the camera. She might look at me, but not my linens. My clothing. It's like hot here today. I was like sweating on the walk, and I bought this like hardcore, not super, it wasn't like an Arctic weather coat, but it's like a, it's like a colder weather coat that I bought from Helly Hansen that should be like super duper, like, like sailor, dock worker level coat. I put it on and took it for a walk, and I'm like sweating. And I'm just like, oh my God, I'm gonna die here. It's like 1,000 degrees in this coat. There's no air exchange. What are you doing, Bubby? You settle? Good girl. She's gonna put her little face right over the edge of the, okay, she's gonna lick herself apparently. Don't look at this Twitch. Don't look at this toss violation. Okay, there we go. That's my sleeve. What are you doing? What are you doing to my sleeve? That's my sleeve. I like that sweatshirt. What are you doing? Oh, fine. Okay, so she settles with her face facing the opposite direction of us. Big ol' puppy. Oh, she's off. She ate a spicy potato chip that had dropped on the ground, drank a bunch of water, and then finally got the message to do her little bark to go outside. Hi, what you doing? What you doing, Bubby? You good girl? You good girl? It's good puppy. It's good puppy. Here, look at those people up there. Look at them. There's a bunch of people watching you. Yeah, I'm watching you be super cute. Be super duper cute. Because you're super cute. Yeah. You good girl. I'm gonna give my puppy a big hug. I'm gonna give her a big hug. Oh, thank you. Thank you. Good girl. All right, you are released into the world. You can do whatever you want. She knows how to do stairs now, so she's able to get up and down from the shop. No air exchange, disappointed insulation. Oh yeah, but I mean, there are different coats for different purposes. So for wandering around in a suburban neighborhood where it's just a bit nippy is a little bit much for like an Arctic weather coat. She is almost 7 months old. On the 7th, I believe, she will be 7 months old. So she's getting there. She's getting big. She's been growing. She's also not here. Where'd the puppy go? I guess she no longer wants to be around the guy who's yelling at the furniture. Canadian. Yeah, you guys need him. Well, no, everybody's wearing, what is that brand? Canada Goose or whatever? Everybody wears that, and they're like sweltering, and their arms and legs are, their hands and legs are cold. Like, this is like the fashionable brand, but it's like an Arctic Circle coat. It's like a super hardcore coat. How old do corgis get before they stop growing? That's a good question. I have no idea. I don't actually know the answer to that. I'm gonna open up Paint here, my CAD program. I made the mistake of having, because we have like ingredients to make pizza, and I was like stretching the dough and everything. So I made the mistake of having, hold on, I gotta open the right file, so I actually have to concentrate. I made the mistake of making a sausage, egg, and cheese out of the ingredients. So like pizza sausage chunks, mozzarella, and then 2 eggs in a bowl, microwaved, and I ate it on potato bread. So it was like the worst thing I possibly could have eaten. It's so heavy. So I'm like feeling a little weird, a little sick. I've seen that lately in Ontario. It's quite odd. Most of the people that were not born here wearing them. Yeah. I mean, Canadians are in shorts until it's like literally like freezing, right? At least we are here until it like the first snow is when people stop wearing shorts. Like, so having a massive winter coat is kind of weird. People got sucked into the marketing. Yeah, I hear like the areas where you don't need them, it's like super dense with those coats. So I actually, and this is, I'll go over this again. It's just something to talk about right now, is I just gave up. I gave up and I used the line tool and I made a schematic. I made a schematic out of it and I unified the whole schematic. It's not clean yet. There would be a lot of rearranging that I would still do to this, but there are certain functional like blocks of this that I've got kind of sitting here. So we'll check out some of the lesser known parts, but it looks like it's kind of interesting because like there's repeating structures. Like this right here goes into another one, but this one has 9 volts on it, and then that goes into this structure here, and we know exactly what this structure is and what it does and how it functions, and then this hooks into there. Negative 28 with gusts of 100 is a bit nippy. Yeah, it's a bit nipply. 14. Yeah, what is it here? I think tomorrow it goes up to 60 degrees. 60 degrees Fahrenheit. And today it's like 47, which is like it's like rolled up sleeves weather. Like I can go outside in this and I will end up sweating. And people are like, how are you wearing that? I'm like, look, man, I'm a cold weather person. Pretty nippy in the house with no heating. Yeah, why don't you have heating? Well, if it is 14 degrees and you don't have heat and you're using your computer to heat the room, consider making like a pillow fort. The place I rent doesn't have heat. How does that work? You need to like make a smaller area out of your space so that you can warm that properly. That's dangerous. You're gonna be 70. It's gonna be 70 where you are. Jeez. All kinds of different geography. I take it you're more southerly. Yeah, I know. It's like how do you have an apartment that's at like dire temperatures and not have heat? Got a photo of the snowing from the window when it was negative 28. What the hell? Yeah, that's kind of wild. What up, Terts? Yay. So I drove my car again, and I got all the lights on again. Not the same ones. It's a different combination of lights, so I have to hook up the computer and let it tell me what's wrong. I'm so done. Cold was the best sleep I got all year. Might have been the last sleep you got if it was too cold. New Mexico? Oh, that is more subtle. What is wrong with me in my head? I was like, my God. Like, of course, it makes total sense. Yeah, 70 degrees in New Mexico is like chilly, super chilly. People are wearing like the big puff coats, the big New York City coats. Where's that data sheet? I'm looking for the chip. What is it? Well, it should be on this search, because maybe if I go to the regular results. Hack a day. Best DIY. Ultra sensitive. EMF detector chip. Oh, it's like LM. Hold on. I'm gonna sneeze. Whoa! Jeez. Sorry, it's just rat dancing. Rat jamming. Log jamming? Okay, I gotta go look for that. I gotta find out what chip it is. Can't be exposed to the extreme cold of 70 degrees Fahrenheit for too long. We die from exposure. Jesus. Yeah, because New Mexico's like on the surface of the sun. Oh, I think I've lost the chip. I'll have to look it up again. So I saw a cool video with a bunch of startups of nuclear reactors, and that led me to a channel of, I guess, urban explorers who seem to be getting into some of the weirdest fucking places I've ever seen. Like, they are getting into places that really I did not expect somebody to be able to go into. For instance, there was they toured a nuclear reactor that had been decommissioned, which, you know, decommissioned nuclear reactor, they've got power coming in from the outside, and they have radiation detectors on the walls all over the place, because all of the radioactive stuff has been very carefully removed, right? Yeah, Proper People is actually who I was watching. They're really good at the cinematography, but man, they are dumb sometimes. Sometimes they're a little dumb. It's okay to not know things. But anyway, they're looking at this decommissioned nuclear reactor, and oh my God, like, they just walked into this facility. They just walked in. They're a little zoomer for me, but I'm okay with it. But yeah, they somehow got into the facility, which I don't know if they're like greasing palms or if they just naturally find all these really cool places that nobody has filmed before. Dunno, but yeah, they just casually walked up to this reactor building. The door is ajar, and they just went in and like toured the whole place. Absolutely wild. I can't believe that you could do that, but I guess if it's been decommissioned for a long time and they're not doing anything with the real estate, you have like one night guard who's probably asleep most of the time. What county yeah, they just walked up to the reactor. They were in the reactor, like where the reactor was. Where is this reactor? I have no idea. Yeah, there was when they went into like all of the different areas, and so there's like office area and like repair, electronics repair, and like lab space and stuff like that. And the equipment that was left behind was pretty interesting. Like, there were a lot of very, very nice dials and stuff like that were left behind. But even weirder, they went to the control room of the reactor. Even though the reactor's gone, there's still power running into the building in order to, you know, keep systems alive and stuff like that. But holy hell, like, you know, there's some part, like, facets of the building that are still like running, which is just wild. Just wild. I'm looking for this chip. I forget what chip it is. EMF, bar graph chip. That's not it. It's very similar, but it's not quite it. LM3914. Data sheet. Vagrant Holiday. who sneaks into an abandoned prison island and explores it at night. Wow, that's creepy. 3914. We're gonna poke around with the oscilloscope today and really put this thing to bed. Oh yeah, is the stand light working? Make sure that that's working. All my lights are functioning. Yes, I heard it click. There we go. Sweet. All right. Yeah, those are like noise. Those are like static noise all over my image. What's going on here? No, I mean, it was actually decommissioned, so there's like nothing radioactive in there at all. The only place that you could possibly find a little bit of radiation might be where they used to store the rods, but they're like sealed. They're sealed up. Every other like iota of radioactive material has been removed from it. That's that whole thing. Like decommissioning nuclear power plants is like a big deal. Like it's a big industry. But yeah, there was a lot of like scaffolding everywhere from the people doing the cleanup and stuff. Wild. It's just totally wild. And it's funny that all of human existence and technology boils down to we are really, really, really good at spinning stuff with steam. We're good at heating up water and using that water to spin things. Absolutely wild. I'm gonna make a super cut, and it's gonna be a 6-hour-long video of just people reminding me that Start Soon is up. It'll just be, because every single time I've streamed, every single time. Yeah, not all electric, not all, hashtag not all electric. We got turbines and solar panels now, and those are slightly different. Although a molten salt solar farm is still heating up water in order to spin a thing. But for all of our technology, we found a rock that was a little warm, and we put stuff around the rock, and the rock became hot, and we went, what if we boil water with that? Because then we can make that into electricity. That's all we do. That's all we ever do. Motors are too convenient. Motors are math. Motors are math just encapsulated in a little shell. We need a Start Soon counter. Oh, we'd be in the hundreds. But yeah, boy, you know, like there for a little while, people were working on like nuclear batteries, where we would have some kind of like a pitted surface, and as the isotope decays, that would somehow, I don't know, power a loop, right? But that never really came to fruition. I don't think we've ever really heard anything about that, or they're still just working on it. These articles come out from places that are just looking for funding, right? They're just looking for that little bit of extra funding so they can get their PhD and then scarper off into another operation. We see that a lot, especially with diabetic stuff, with like the cure for diabetes is only 5 years away, I have heard, for 20 years. So, you know, I don't know to what end radioactive batteries are actually going to be a thing, but it's just interesting to me that the only way that we're producing electricity out of radiation is it's kind of warm. Let's heat some water with that. Beta voltaic cell excited by tritium with a phosphor. It's always a phosphor, isn't it? There's always a phosphor involved. What is up with these people creating the bleeding edge of technology on the backs of phosphors? It's always phosphors. If I put a phosphor on this LED, I can make it purple. Just fucking Nobel Peace Prize. Music is getting a little bit more violent. You would think that we would have a better way of capturing nuclear energy. One of the cool things that I watched as well over the break, over one day, was a novel approach to nuclear fusion, not fission, fusion, where they would take helium-3, I believe, and some other stuff, some other nuclear spaghetti, and they would spin it in two coils that were magnetically like basically they'd use magnets in order to keep it in a ring, like a toroid ring, and then they would launch the two toroids at one another. And at the time that they coalesce, that's where you get, yeah, I think that was, yeah, Real Engineering's like long video, but they would coalesce, and at that point, you would have a decaying, highly energetic magnetic field. So all you need to do, and they would use a magnetic field to contain it, but when they stop containing it, it dissipates. And that dissipation of all that energy turns, in the presence of a coil, turns into energy. So that's actually really exciting, because that is a novel way that does not use steam in order to create power in a way that's only going to contaminate the stuff that's surrounding that engine. Pretty cool stuff. I don't know if, unlike the whatever the other type of fusion thing is, the I think that one's like toroid or something like that. I forget what the terminology is, but that one you can actually create the helium with, whereas I don't know if the magnetic donuts smashing together can. But that basically, the whole operation is tons of capacitors, and they it was weird because it was such a hodgepodge operation for their first like smaller, yeah, the tokamak I believe you can use to create the helium fuel eventually. So you have to like hedge your bets and send most of the world's supply of that stuff to one of these things, and when it finally spins up, it'll be able to create its own fuel or something. I don't know. No, wait, that was the donut one will eventually create. I don't know. It's wild though. But the operation that was doing sort of the donut collider, that one was like a hodgepodge operation of a bunch of capacitors that they were able to source from wherever they could. So it was a bunch of like, you know, 000 gauge wire going into what looked like Home Depot shelves that were just full of capacitors upon capacitors, because they do blomp. They put the two things, the two donuts together, that dissipates, and it creates a spike in power. And so they have to take that spike in power, store it, because if you're going to actually provide power to something, it needs to be, you know, consistent. So I would assume that much like in the cylinders of an engine, you would have a bunch of these things, and they would be going pop, 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 and then you'd put that into the capacitors, and then be able to spin off stable power. But it's cool because it's like, you don't need turbines to spin to create power. What's the power MCU on a spacecraft? Man, they should have put those into the Expanse, huh? We need more heavy water reactors to get more tritium. Yeah, fucking crazy. I mean, the nuclear diamond batteries were touted as being the future of technology, but they only put out 100 nanowatts of power. You could do like you could put one in a brick, right? You could put one in a brick in a wall, and it would power like a little Bluetooth low energy jobby, and like put a super cap in there and just have it check in every couple years. I missed the signal. I gotta wait 2 years. But yeah, crazy stuff. Crazy stuff. It'd be cool to see. I mean, those tokamak reactors are fucking enormous. If you saw if you have seen any of the shots from it, it's like big industry. I love that kind of stuff because it's like changing the course of humanity. It really is, because it's like, you know, what are we gonna do to generate the power needs of a more and more digital society, and yeah, and make it safe and all that jazz. That's pretty cool. The amount of investment money in something like that to make something out of, what is it, titanium that's like 3 stories tall? Absolutely wild. Absolutely wild. I'm in awe of the lad. You know, for an EE, you would think that I would have a couple more 9-volt battery connectors kicking around. They seem to use them all over the place. Star Trek 4 is the answers. What, whales? Yes. Wait, which one is RTG? They're heavy. They can come up with a bank of lightweight nuclear batteries that will allow more mass for science payloads. Oh, wait, RTG, is that that's not the nuclear battery and satellites and stuff. What's my glucose level doing? Oh, good, great. climbing still. If one thing that's been discussed lately in the realm of diabetes and the expense of insulin is they keep calling specialty insulins, they keep calling them designer insulins, and they're like, oh, it's a designer insulin. It's like, no, there's a bunch of different types of insulins out there, and the latest ones, the latest formulas are very fast acting. They're not really designer insulins. Yeah, what differs in the insulins is generally going to be the reaction time. Yeah, designer insulin makes it sound like a luxury good, and it's not. If your doctor is prescribing you that insulin, it's because you need it. I am on the equivalent of Humalog. It's I actually forget which one of the, I think it's like a Pedra or something, but it's an equivalent of Humalog, and that formula has been around for 20 years. The reason that you guys see me going up and down the way that I do is because I don't have fast-acting insulin. If Cluck J pops into chat ever again, like he was showing his charts, and his charts on the same devices are much tighter. You can see the reaction to carbohydrates and the immediate fall of the glucose level, whereas with me, it's, well, like the climb is very slow, and then the reaction is also very slow. If I were on a faster acting insulin, I would have a much better time of managing my glucose levels. So now I'm gonna feel all gross for a little while. Look at this guy having functioning body with his designer insulin. Yeah, right? Look at these people with functioning pancreases producing their own insulin. Get high off your own supply, huh? It just really bugs me that there have to be these contrarians on the internet that for some reason are saying like diabetes are a bunch of whiners. Like it really pisses me off. It really does. It's wild. It's wild stuff. And then of course they somehow get the ear of the people who are making the decisions. You know, for instance, like having the $35 insulin cap only apply to older Americans. Who? Why? What's that? I have to survive diabetes long enough to get $35 insulin. That's supposed to make up for the financial ruin that comes with managing your own diabetes. That's a weird thing. Anyway, I'm not gonna totally harp on that. Edward Snowden Cullen followed you yesterday. Neat. Guess you're allowed to do that on Twitch. You could just imitate people. American diabetics should be whining about the price of insulin in the US. We are as vocally as many of us can. I believe we should be throwing rotten vegetables at politicians because of this. I don't advocate that. Don't think that's a call to anything, but whatever happened to throwing rotten vegetables at stuff, right? Did people used to like show up at the movie theater with like a bag full of rotten vegetables or something? Or the whatever it is, the what is that called? The theater for the variety shows. I think there was a name for it. Macronutrient aggression. Throw kale at stuff you don't like. And did that spill over from the theater? I don't think it was it specifically vaudeville, because I was gonna say that, but I didn't. Anyway, do those people, like, does that behavior translate out into the rest of the world? Were they like would they like walk down the street and somebody would be like, hey, buy this newspaper, and they're like, no, I don't like that, and they throw a rotten vegetable? Was it ever a real thing, or was it made up by a movie? I don't know. I mean, veggies were pretty important back then, right? There were designer vegetables at them. A tomato. Throw that, because it's spoiled. But it's designer. People being pillared. I guess you go visit the pillory with all your rotten vegetables. Haha, justice. That's the only use for kale. I don't mind kale that much. Something to do with the way they got bills passed through the Senate. You can only really do things, yeah, that are directly related to spending and taxation. I don't know. It's just the fucking stalemate that politics has become. Fucking annoying. Every single. Well, I'm not. Nope. Not doing it. I'm not doing it. Yeah, medieval. Dutch mob boiled and ate a prime minister. A few years back? Well, I'll reopen my web pages. Hello? Oh, I think I just froze my Steam. Well, there's the Stream Deck. Stream Deck's like slow. I don't know why. Yeah, like a few years. Few hundred, 1600 or 1800. That's like back in the day. Back in the day can be yesterday, or it can be the Stone Age, or it can be the time that dinosaurs were around. Back in the day, all of the universe was smaller than a pinhead. Not that long ago, when you keep in mind how long time has been a thing. It's true. True. Stream Deck has ghosts. Yeah, we'll have to detect them today. It's been a minute. Yeah, it's been a minute since all of the known universe was smaller than a pinhead. Just a few years ago. Just a few years ago, a lizard crawled up onto the land, and now I got to pay taxes, which is supremely unfair. Stay in the water, dumb lizard. My hair's not cooperating today. I don't think I can get a handle on the hair today. Yeah, I gotta schedule a haircut. It's been too long. It's been like 3 months. It's not good. The barber's gonna yell at me again. He was so mad at me last time. He had to charge extra because of all the hair. Whoops. Audience members in the cheap seats of the vaudevillian shows often like to chuck peanuts at performers. Leading the creation term peanut gallery. Well, I didn't need to know that, but I guess I do now. Now I'm burdened with the knowledge of that fact. Okay, so I'm up to date. What's IED part of your bio? I used to work as a consultant in DC, Virginia, with a big 3-letter agency reverse engineering IEDs from overseas. U.S. military put a lot of effort into figuring out what the fuck was going on over there. And so we were sent electronics and we had to write reports on exactly how they function. It's an article that I don't think you can really find anymore called Left of Boom. That explains it all. So does the human brain work that way? If you learn something, is it displacing something else? People like to think of the brain storing things as sort of analogous to a hard drive, but that's not how it works. It's not how it works. Did your office have 5 walls and an NDA? We had security clearances, so, you know, hey, there's a lot of stuff that we don't talk about. But I'm like the master of deflection out here, so don't worry about it. Got man flu. Not accountable for what I write, say, or do. Is that like a phrase, or are you actually saying that you have the flu? Yeah, that's not how the brain works. That's not how it works. We know a lot about how the brain works, but it's not like a hard drive. I don't have to delete a file in order to put a new one in there. It's much more nebulous than that. All right, sorry, just looking at my windows here. So I guess the dog's done visiting. We don't have the puppy to look at. I got all my tubes. I got all the tubes. So one thing I'd like to try with the tubes in the near future is to pinch and solder, or pinch and solder one end, fill it with water, then pinch and solder the other end so that there's hopefully almost no bubbles in there. Pre-pressurize it a little bit and then twist it around the laser so that we can have a nice tight coil around our laser diode carrier. I don't know. What do you think they were? We just looked at electronics all day. There was mostly. I had a couple side projects that involved weird stuff, but other than that, that's all I can say. That's all you need to know. It was my job. You'll find many more answers in the article Left of Boom, if you can find it. I'm gonna get a glass of water. Are you on drugs? Article or book? It's an article. House music. If you have like a camping tent, you might want to put the tent up. Basically, if you want to get your heat pump to do better work, you need to reduce the amount of area that it's heating. So a pillow fort would be a good thing to build right about now. Anyway, let's get started. Turn off BRB. We get the music out of here because it's about to pop. Oh my God! Jesus, I hate it when house music does that. When they repeat a very short noise a lot. Okay, hi, welcome to the stream. What are we doing today? Well, we are going to reverse engineer a ghost hunting tool. Now we've already put quite a bit of effort into this. I have been doing circuit analysis and basically just all the stuff that's in my wheelhouse. It's the stuff that I love to do. And it's stuff that I did for 8 years of my life. I should probably just round it off and just say 10 years. 10 years of my life, I did reverse engineering of circuits of this nature, sort of like this. I know a lot about reverse engineering, and we've had a lot of lessons along the way. We're at the point where we need to figure out how this thing works. Now, not to torture myself to death with all the technicalities of this thing, because I'm trying to also put on a show. This is my show. This is, in fact, hold on, I gotta get back to this scene. This is my show. So I would like everybody to calm down and telling me how to run my shit. Anyway, I'm trying to keep this entertaining and I'm trying to keep it fun, and I'm trying to just sort of go over the basic operations of reverse engineering. Now, we're doing that by looking at a piece of ghost hunting equipment because it's funny to debunk idiots. However, this piece of equipment is actually a legitimate EMF gauge. The fact that the ghost hunters have sort of fallen back. I was looking for a better word for that. I can't find a good college word for that one. They've fallen back into the interstitial space between known things, and they've started to analyze noise to the degree where any type of noise is indicative of there being a ghost. You're about to become a fucking ghost. You shut the fuck. No, I'm just kidding. We don't have a ghost for calibration. This is an EMF gauge. I mean, I could probably wave a magnet in front of it. This thing just pops off with anything because there's a lot of EMF in my shop. My freaking lights put out quite a bit. You can see it on the O-scope. Flipper Zero. Oh yeah, that thing. Yeah. That little RF hacking device would probably put out quite a bit of EMF. I mean, anything radio related. We don't know what frequency it's sensitive to yet. We need to measure the coil to see what the antenna is bringing to the table. It's a big antenna, so I'm gonna guess that we're talking like CB radio frequencies and stuff like that. I mean, all they would need to do is put it at 60 hertz, right? And of course, first thing everybody says, EMF tool, you're just reading 60 hertz from power outlets and stuff. That's not what they do. They don't do that. They're aware of that. The first thing you think of is the dumbest thing, and they're dumb. They know about the dumb thing. So they, of course, have a lot of stuff to say about avoiding 60 hertz noise, even though they don't know where the stuff is coming from. So, yeah, I mean, they're talking about electrical noise, and they're probably all carrying cell phones, and they got camcorders and stuff like that. So, you can't help these people, but it is fun to take a look at this device and figure out precisely how it's working and what it's sensitive to. We're going to try to get to the bottom of that, and if we can't, we'll work with tubes today. This is sort of the end of the cycle of reverse engineering a device. The typical steps that I take when I reverse engineer something is, one, look at the circuit board. What is it telling you? What does the thing do? If you don't know what it does, look at the chips. What do the chips do? Look for power input and trace it throughout. Basically take the power input and then the sequence of events that lead you to the output of the device. That's sort of reverse engineering. And then from there, once you get a schematic of what's going on with all the circuit stuff, for better or for worse, sometimes you can just take it carte blanche and then organize, or sometimes you can take the data sheets of the chips and they will suggest layouts for how to use their specific ASIC. They'll say, oh, you need this, that, and the other thing, and they'll provide you with a circuit. You just copy that circuit onto your personal schematic, make sure that you're accurate to exactly what's there and what connections are made, and, bada bing, then you know everything about the device and how it functions. If you still don't know what it does, time to put it on the bench. Start poking around with the oscilloscope. So that's where we're at with this thing. I've figured out what the schematic is, and I've done all of my best to assemble it and make it neat and organized and easy to read. And here, where is it? Where'd it go? Here it is, right here. So I actually broke down and I used the line tool. There's only 2 zooms in MS Paint, so it's a little, we either can't see the whole thing at once or it's too small for you guys to see. We have a bunch of things going on here and a bunch of interesting structures to our circuit. For the most part, the stuff with the transistors, I'm kind of guessing at what the form is, but this right here, this set of operational amplifiers, we've seen this before, and I can pull it up in a minute. What I know about ghost hunters, they look for EMF anomalies, not just normal EMF. Yeah, this is just EMF. This is not this tool, which was listed. What is abnormal? Yeah, like what's an EMF anomaly? EMF is an anomaly. Like that's. Yeah. Can I make an analogy? No, because it's just like it's like this pressure gauge looks for special pressure anomalies. But it's a pressure gauge. That's all. It's just measuring pressure. Like that's not going to be the last time I say it. Are you high? Anyway, so this the structure of the circuit was kind of hard to rein in, just because there's this sort of like floating the ghost line. This thing here. Oh, we need to change my pen around to be red. I need red pen. I need to be thick, dummy thick pen. So this right here, coming off of the coil, something's going on here, right? We've got a Zener diode, which will limit the voltage of this thing, whatever's coming out of this coil. We have a transistor that's switching it down to ground. We have all the way over here, we do have 9 volts going through a 4 kilo ohm resistor and then a 3 kilo ohm resistor that can charge the capacitor and activate Q7, but it also goes to all this stuff. Now, there might be errors in the schematic. I didn't have time, guys. I did this yesterday, right? I put this thing together yesterday, and it was a lot of work. I didn't have time to double check myself. Part of creating a schematic and reverse engineering a device is being very, very, very careful about the details. The details are what will kill you. Like one wire that you accidentally think is connected can completely change your idea of the layout and how it functions. I've gotten it into a state where I believe that there's a decent amount of I've gotten it into a state where I believe that we can analyze what's there and with a reasonable amount of certainty figure out what each stage is doing once we back it up with the oscilloscope. But I still would like to check this over more carefully. We're not going to do that because it's boring. That's the work part of this work. Like, for instance, Z1 and C1, I could move anywhere. I could put them anywhere on this entire line. It could go up here, right? It could go right here. I put it right here just because in the grand nomenclature of all of these different components, there seems to be a flow of 1s, 2s, 3s, 4s, 5s, and 6s as we move towards this part, the op-amp part of the circuit. Now, the fun part is, when I was looking up these op-amps, I said, you know, I'm not going to look up the EMF chip. I'm not going to look up the EMF chip because it's not going to be relevant. It's going to be some ASIC that works in a completely different manner, and it won't be relevant to what we're looking at. And it turns out the LM3914 dot/bar display driver internally, scroll, is exactly what we have. This right here. So you have a resistor ladder that leads down to ground. This one is all 1 kilo ohm, although I have seen like things where they have different values. In this case, it's a resistor ladder, so every extra kilo ohm is another activation on the comparator. Then it's got a signal in with a buffer that it compares to. So if those are equal, enough voltage comes out the front in order for it to blah, 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 blah. And then off the top, we have a resistor going down to ground, and that determines LED brightness. Well, that's pretty much what we have here. I just rearranged it a little bit. Our values are a little weird. 30K, 15K, 115K, 16390. They're kind of all over the place, but we have the resistor to ground here. We have this, I guess, not really signal in. What is that? Is that signal in? It's like a reference. This is like a reference in. The signal is coming from here, where we have a little structure with a couple diodes and a 100 kilo ohm resistor, right? Well, moving through this data sheet, they have some suggestions. Some gentle suggestions of what, by the way, a buffer with a diode. Yeah. Scroll. Keep scrolling. Keep scrolling. You're not there yet. Come, settle by the fire. There's a transistor switch operating that. Keep scrolling. In one of the application circuits, they had a buffer that looked very similar to what we have going into this thing. Let's see. I guess we're out of the. This data sheet doesn't have the one that I saw. That's all the mechanical stuff. Yeah, this is like a bar dot line graph driver, and it basically consists of a bunch of comparators in a big ladder. So oddly enough, that's exactly what we have. And I'm sort of scrolling through all the different circuit suggestions here. Nope, not finding it. Anyway, it's like an input buffer. So my guess is, and this is just a guess. We'll verify it with the what do you call it? We'll verify it using the oscilloscope. But it seems as though What is that doing there? It seems as though there is a potential for a sort of mid voltage here. So we would be making this like 0 as reference, and then it could go high and low. We're doing that with the Zener diode by clamping this thing to a particular voltage. For some reason, we also have a transistor triggering off of it. They're not too concerned. Let me just, cat's out of the bag on this one. The engineer that put this circuit together is not terribly concerned with filtering out noise. If they were more serious about filtering out noise, this would have a portion of the circuit board where you would have the antenna detector, and then you would have another portion of the circuit board that was shielded with maybe even just the minimal ground plane on both sides that's stapled together with vias, but they don't have that on this circuit. The circuit is, boy howdy, is this circuit lazy in a lot of different facets. There's half of a ground plane on half of the circuit board. The part where your hand is going to be holding the thing, that's where the antenna is. The antenna runs the periphery of the circuit board, and it's all the way towards the battery. So if they really wanted this to be a ghost detector or a proper EMF detector, because remember, it wasn't made as a ghost detector, it was made an EMF detector. They probably should have put the antenna up here, would have required more circuit board, but if they put ground planes on both sides, then you're actually getting the external influence instead of some kind of an internal craziness. If they filtered out the noise, they wouldn't have anything left to detect. But that's like the noise that's always going to be there, right? That's going to be the noise floor of your own internal device, unless they're just trying to exemplify, they're trying to highlight the weirdness that can happen. Because like nothing is happening with this LED. This LED just powers up, which for some reason, I guess this goes low during operation, even though we are charging a 220 UF cap. That would have to go low, and I guess that would mean this has to be triggered, which would mean that the potential of this loop through the 3.3K, that would have to go low, which would be switched by this. So this might be oscillating. We'll have to see if that's oscillating or not. These two transistors, whenever you draw a transistor facing the opposite direction, you're either backed into a corner or you have an oscillator. So next episode, we actually modify this to actually work. I don't have like a, what is it? Frequent, what are those radio frequency scanner things? Why can't I remember? Why can't I remember the name of this piece of equipment that I've wanted for centuries? You can buy RF probes for those, and then you can do a lot of really cool stuff with RF on it. We've been able to do a lot with network analyzer. Thank you. Is that right? Network analyzer? I don't think that's the right. Let's see, sweep, electronic equipment. I don't know why I can't remember what this thing is called. It might be a net. You're probably right. Radio frequency, sweep frequency. Let me just look up network and analyzer. Oh, spectrum analyzer. That's what I'm looking at. A spectrum analyzer. Yeah. I've wanted a spectrum analyzer for a long time. You can get little antennas for them too, so you can hunt around for actual EMF on a board. But yeah, the antenna's in the handle, using the person holding it as part of the antenna system. You would be like a reflector, and so whatever EMF you're looking at, unless you're holding the device up to it and only pinching it, if you hold it up like this, you're looking at stuff behind you. Or the cell phone in your pocket. So this might be oscillating right here. That might be oscillating. And if it is, that would mean that whatever signal we're getting out of it would be pretty much originating right here. And the signal that we get out of it is then going to go through whatever the hell this structure is. It looks like a PNP transistor that's being default with a 10K held quote unquote high, whatever the hell is in this part of the circuit. I think we're in kind of an amplification mode. I think what we're doing is we're taking a very small signal here and we're putting it through an extremely high gain amplifier, and then we're doing it again, and this time we're giving it 9 volts to work with, and then from there we put that into our bar graph generator, which is a bunch of comparators on a ladder. I don't know why the hell this is part of the connection here. It doesn't seem like it really needs to be, but it is. Maybe it just introduces more anomalies into the whole rest of the thing. But that is there, that connection. I vetted that one out. So as the voltage level here goes up, more of the LEDs get activated over here. Now this is, of course, this is actually the first LED, the least sensitive one, and that one for some reason gets an unamplified signal. Well, that's not really our signal. It's just like a part-way power. I don't know. This part is a little baffling to me. So we'll take a look at it. We'll see what we got here. I would have expected this circuit right here just to be completely separate. It seems that the first LED is actually doing something. Most of the circuits that you look up online for an EMF detector, they actually talk about the first LED as just being a power light, which this isn't. It's actually measuring something. It gets so pricey that you rent them for the testing phase. Yeah, spectrum analyzers can get really pricey. There was a good one that I found that was it's actually portable. I don't need it to be portable. There's a portable spectrum analyzer. It's about $800, and I was really tempted to buy it back in the day. I could have had 1,000,000,001 uses for it. Every antenna in my life would have been perfect. What you can do with a spectrum analyzer, chat, is you can do a SWR. It's like a reflection test. When you have an antenna and you give it RF energy, it starts wibbling in the frequency of that RF energy and giving out energy. And so if you send a whole bunch of white noise into an antenna and analyze what you're getting back, you will see that that energy dips off at the frequency that the antenna is tuned to. All this RF stuff is very simple when you boil it down. You're sending energy out into the antenna, you're getting all these frequencies back. When it dips, that's when you know the frequency. That's the frequency of the antenna. So then you can clip off little bits of the top of the antenna until it's perfect. Or on more expensive antennas, there's like a little grub screw at the end that can lengthen or shorten your antenna. Pretty cool stuff. And I actually have the equipment to do that. I bought some mini circuit stuff. You can buy just like a white noise generator and then a particular type of splitter, and you can hook all that stuff up to the oscilloscope. I don't think it doesn't give you as clean of a sweep, I think, but you can still kind of hone in on what the SWR of an antenna is that way. Cool stuff. I like RF. I wish I had learned more RF. That's one of my big regrets about the IED job, is that I worked with an engineer that had his own company, and he was like, I'm getting old. I'm not going to run my own company. I'll do RF for this IED thing. And he taught me a lot of stuff about RF. A lot of stuff I didn't know. It's kind of a dark art. Dark art. All right, so what I know of this is that this is triggered by varying voltage levels, right? Coming in here, and we're eliminating any AC properties of those voltage levels with a capacitor. A capacitor in line, if we get a wibbling AC signal, that will actually cut off the AC, and then you only get DC coming out of the other end. Or wait, is that a DC cutoff and we only get AC? Uh-oh, wait a minute. Hold on, I think I got it the opposite way. Oh God, dyslexia in electronics is not a good idea. Hold on, wait one sec. AC canceling capacitor. You can see very plainly that by hiring an engineer, you are not hiring somebody who knows everything. A lot of engineers get that confused. You're not hiring somebody who knows everything. You're just hiring somebody who knows what to Google. They know what to Google in order to find the answers. Like this answer that I got right here in front of me. Look at all this wonderful information that I was able to find very plainly and easily. Hello? Is anybody there? Well, I know I don't have any viewers, but I mean, at least the web page could load. Okay, that didn't work at all. This is the page. I need like the most basic, stupid explanation. I think I got it backwards. I think in the presence of AC, like a capacitor will let. Yeah, that's right. I remember it now because of the meme. Wait a minute. The meme is the electronics meme. Oh dear God, I can't believe I'm relying on this. A capacitor will let through an AC signal because the AC signal goes like this, right? Because it's AC, it goes up and down like that, and the capacitor lets it through. But you know, like a but DC gets blocked because it hits up against the wall. I can't believe that I relied on a meme in order to make me remember that. Jesus Christ. But a capacitor will do a phase shift on the AC that goes through it. If it works, it works. Yeah, I guess it's a mnemonic. It's kind of amazing that the work speed of an engineer is a linear relation with the internet speed. That's very true. Yes, an actual meme on my stream. Can you believe it? I try to stay separate from other creators on this platform. Like, for instance, you know, like, I don't watch Flatulent Gonad. I think is the only person that I do like occasionally watch, but I try not to because I will take their memes and I want my own memes. We're supposed to be generating content, not regurgitating it. You were the chosen one. See, that was regurgitation right there. Anyway, so this circuit structure right here, we know. I guess we're blocking DC. Blocking DC. We're buffering, and I don't know what the hell this is about. I mean, again, going through, it's like we're taking a low level of rectification here. Because if any of the signals go too positive, they'll go through this diode. And if they go too negative, they'll go through this diode to normalize. Really weird. It's just like all canceling any of the signals that we get on this end. So we'll have to take a look at what it looks like on the other side of C8, because I think that'll be pretty interesting. And then all that stuff is filtered out, and I guess what we get on the other side, yeah, I guess it's clipping it, but all we get on the other side is probably a voltage level. Probably. I mean, we've got, what is this doing? This would be current limiting? No, that wouldn't be current limiting. I mean, that would be a weak pull down, so that when, because we've got a capacitor sitting here, and these are probably what's called high Z. High Z just means that there's pretty much nowhere for the electricity to go. There's a very, very, very strong resistance on those pins. They're not going to affect what's on the other side. They're just going to see what's there. They're not going to affect it very much. So these are high Z. Hold on. These are high Z. The negative inputs, positives probably are too. So the 100 kilo ohm resistor is there because if you have a small voltage level sitting here and you have got diodes blocking it in either direction, then that voltage level is going to stick around, and you don't know for how long. It'll eventually dissipate, but it will stick around. I've seen transistor circuits that take minutes to dissipate that energy. So you put a 100 kilo ohm resistor there. 100 kilo ohms, a lot of kilo ohms. So that's barely going to affect the output of your circuit, and that will bleed off any excess current that exists in that area. When I say I've seen devices that do stuff like that, you guys can pretty much draw a line from what I'm saying to my bio. All right, so I see structures here that I want to look at. We're blocking AC on this line, apparently, going into the base of the Q1. Q1, this will have to go low in order to activate Q1, and then that'll go low through the coil. What the hell's going on there? C1 would be smoothing out whatever's there. Z1 is limiting the amount of voltage on this ghost line. That voltage gets switched through Q2. When it gets switched through Q2, it's going to pull Q1 low and switch it, which will pull the rest of this low and pull this low eventually. So it's like inducing, I don't know, I feel like it should be oscillating. I feel like oscillation should be occurring here. And then, of course, the capacitor and resistor are going to have a weird effect where if we pull this through the 20K, we'll pull it low. C3 is going to discharge in this direction. It might not have enough charge. It might just delay Q2 from switching. Same thing happens here. Capacitor starts as a short. These are positively driven, the NPNs. So when that charges up, it'll be weakly pulled low by the 10K. Q2 switches, and we get a very weak AC signal going into N3. N3 then switches, this dissipates, etc., and so forth. You do it twice to get super high gain, I guess, And then the same thing over here, but this time you've hooked it up to 9 volts. You've hooked it up to the full power instead of whatever the hell is on this line. This might be just like a 4.5 volt level or something like that. This might just be a stable voltage. Although it doesn't seem like it should because it goes into a massive coil. But it's coming from over here. This is the confusing part to me. It's coming from 9 volts through a 4.7 kilo ohm resistor that I thought was holding this transistor in power. But it is R5. But then it would have to go through R28, which is 3.3K. What is going on here? This is weird. I thought this would be like a voltage level. So let's check it out. We have a bunch of questions that we want to answer, and that'll give us a better idea of exactly how this works. All right, Ghost960, thanks for hanging out. Everything works with smoke. Listen, we've trapped the smoke, and we're trying to characterize how it moves through these tubes. Because remember that the internet is a series of tubes, and if we've got smoke-filled tubes, I want to know if that's hickory or cherry wood smoke. EE smoke, don't breathe this. So this is our circuit. If you guys haven't seen it, it exists inside of this snappy little case. Everything here is super cheap. This is not an expensive product. This is like $20, which is why I'm doing it, because I don't make that much money off of my stream, and I have to somehow keep afloat. So I can't spend a lot of money on equipment. Most of the stuff you see in the shop is stuff that I bought in a previous life. Anyway, this thing it touts itself as a milligauss reader, which I don't doubt. I think it actually is a milligauss reader. I think the best thing you're going to get out of this thing is whether or not you have a radio device that is currently transmitting or not. I don't really think you're going to be characterizing stuff to any sort of a complex degree. You turn the thing on with a big old lever that it's just a ridiculous plastic tongue that you press down, and it turns the device on and off. Why they didn't use just a regular switch is beyond my reasoning. I don't know why. Big switch in the middle, bunch of transistors and resistors and capacitors sitting around that switch, and then we have the quad op amp sitting here activating all the LEDs. On the reverse, you have no ground plane, no ground plane, by the way, the trace layout of this thing is ridiculous. You got multiple grounds running all over this thing. And again, that's either because in CAD, they ran these things in order to delete air wires. That's my best theory about why they would run it this way, because I think running multiple grounds like this can, I guess, induce some noise. Like you would have, if you isolate your grounds, you could have a digital and an analog ground existing like this. Although you don't necessarily need to do that. I think I read an article that said that you just need like a slight. Anyway, so what's going on here, I believe, is that they were running traces in order to delete air wires. Air wires happen in your CAD program when you should have a connection from one device to the other and you haven't run a trace yet. It's one of the ways that they try to keep your head together when you're designing a circuit board. Some circuit board design programs don't even have that. But most any PCB design software, I mean, hell, back in the day, PCB 123 even had it. So I cut my teeth on programs that were very much like MS Paint for circuits. Yeah, air wires, it's just like a little line that connects 2 pins of something, because in these programs, you put your schematic in one page, that programs the program, and it communicates what things should be connected to what things, so that when you do your board layout, you put all your parts on the page, and then they've got this like rat's nest. It's called a rat's nest of air wires that are all just as the crow flies from point to point. And so from there, you connect everything. Well, when you have a device where everybody is sharing a ground, and you're gonna put in a ground plane, you will still get air wires in some programs. So my theory on what's going on here is they ran a ground connection around to where it needed to go. The Zener diode here, over to here, whatever the hell the ground plane is, and they come back from the ground plane and go back over to the B- connector here. So I think what they did is they ran that in order to not get warnings and air wires, and then they decided at some point to not put a ground plane on half of the device so that their antenna could pick up stuff better. So they decided not to put the ground plane on half the device, and that uncovered all of these sloppy air wires. If you look like down here, you can see, oh, that's not very exciting. You can see all kinds of like weird stuff going on that indicates either they were looking at it from the top layer, or they, well, I think it mostly indicates they were looking at it from the top layer. So this little via right here, or this trace rather, the via and the trace coming out of it, like 45-degree angle into a right angle, that's weird. I think maybe it would have looked less clumsy. I mean, maybe they were trying to get a specific length to the antenna. We'll measure it in a little bit, but I mean, it's basically, look, and then over here, we've got another instance of this where we've got a via going down here, and then we've got this awkward angle coming out and going to another via. Well, that's right here. And there's no ground plane in between these. So they could have just run this across. They could have just put a trace here. They could have just put a trace there. Why would they do this? Well, maybe it was to separate the antenna when there was a ground plane. Then again, their antenna also splits up like this, so things are a little weird. My mate's going ghost hunting soon. This should be useful. I don't know, man. We'll have to see. So there's stuff in the PCB design that indicates that this thing went through a little bit of a revision. The one that Illuminati, the YouTuber, sort of highlighted, and it was somebody else's channel that she highlighted, who did the analysis on one of these ghost hunting devices. That one used the bar graph chip. This one doesn't, I believe, and I don't know for certain. It seems as though maybe the individual op amps are cheaper, or they did this so that it was a little bit more obscure. What they ended up doing with the op amps is pretty much building that chip. They built that chip, but out of less hardware, because they only need 4 lights. The 5th is driven by, who knows, something else. Okay, so we know the name of the game is the thermal camera useful when inspecting hardware? Let me put the brakes on the entire stream and address this one question. Yeah, it is. Because errors in electronics, they're heat. You know, if something's hooked up wrong, it'll heat up. From using too much current, you get heat. So you get to see all the stuff that's going on. Plus, while soldering, it's a lot of fun. Demi's daughter is putting emotes in the chat, which is always cute. It's like putting stickers on stuff. Always cute. I once saw a Volvo in a parking lot where the entire, like right behind the driver, what is that? The driver's side passenger seat window was covered in stickers, and I mean like paper stickers from the inside. I was looking at that like, oh no. How do you, ooh, I would not allow that to occur. I don't know. That's crazy. It's like not safe, and it's going to be impossible to clean up. Anyway, so we've got a bunch of weird stuff going on this circuit. Primarily what we want to figure out is how it's sensing stuff. And I'll get the calipers out at some point, and we'll have to measure how long this antenna is. It's in a coil, which might affect it. It might make it noisier. Oh, God. But it's like, this is a long antenna. This is going a significant distance. This is like a CB radio antenna. So I have a feeling the frequencies that it's sensitive to are pretty small. Then again, it's in a coil, so it might be operating as a coil. So let's probe around this thing. We have kind of an idea of how all the different elements of this circuit are hooked up, so we know where we can poke in and observe different stages of the repeating circuit structure and figure out what those signals look like in reference to question mark. Are we referencing them to ground? I don't know. One of the more interesting ones is probably going to be right here on Z1, because we don't know what's going on right here. It seems like, you know, typically you would have 9 volts coming into your circuit, and then you would put it through a Zener diode like immediately, but that's not what's happening. Zener diode is sitting right on the antenna. Well, yeah, that's essentially what it is. This isn't specifically, and I've said this a bunch of times today, this is not a ghost hunting device, right? Whoever is selling these things got lucky, and the ghost hunters found that EMF is pretty goddamn unpredictable. That Maxwell is a pretty what do I call it? He's a tricksy guy, that Maxwell. And those Maxwell's equations, that determine the strength of RF in particular areas of a room that's reflecting. It's tough. It's tough. They're tough to resolve. EMF is very unpredictable. It can bounce off of anything. You can run the microwave and this thing will start freaking the hell out. No, this isn't hand soldered. The through-hole stuff might be. Yeah, the through-hole stuff is, you can see flux on the board. They were too lazy to clean off the flux. Anything through-hole is hand soldered. The surface mount stuff is going to be baked in an oven, and that's just how they do it. So imagine how many they have to sell to make money out of it. I have no idea. I mean, whoever's making the white label product, there isn't even like a company on this anywhere. It's just whoever decides to sell it can call it whatever they want. So yeah, they're making money off of every single one. They just make more money from the economy of scale. Oscilloscope. I choose you. Oscilloscope. 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 Yes. Yes. Turn that bad boy on. Let that thing warm up. Turn on a power supply because we're going to be doing a lot of probing with this thing. Battery is probably going to discharge after a little while. Although this 9-volt battery probably lasts quite a long time. I'd rather just power it up from the supply so that I know that the voltage going into this thing is 9 volts. And we wait. And we wait. Come on, Rygol. Everybody's counting on you. There we go. What else do we need? Well, this is a surface mount circuit. I could probably use some of my little probes. Some of my little hoggy probes. Where's my little hoggy? That's silly. Tell Bother ghosts aren't real. I knows it. I knows it. I knows it. How do you know ghosts aren't real? Nobody, you have to prove that something that doesn't exist doesn't exist. Yeah, the lithium-ion 9-volt batteries. It's like, never change a smoke detector while you live in a house. We live in a society. All right, next. Let's get some of these guys. Now, these are little easy, what are they called? Oh, these are Tektronix, actually. Little tiny, little grippy clips. Little grippies. I have a different type, and I don't know what happened to them. What happened to my grippy clippies? Need yellow wire and a black wire to be ground. This one's ground. That one isn't. That's orange. What's my problem? There's a yellow one. Okay. Although we might not. I don't know if I'm going to use the grippy clips at the moment. Oh, here they are. These are easy hook. Nope, don't know the brand. But yeah, these little guys right here. Where am I? There we go. So I have a little place to hook up, and then a little gripply guy on the end. So these are actually really good for hooking up to IC pins on surface mount devices. So I can take this right here, and I can just go. You got to kind of come in at an angle sometimes. And go under that pin. Usually, hold on. There's just a little area where the pin goes up to the package. Well, sometimes you can get in there, sometimes you can't. I guess this is probably better for through-hole, but these can do surface mount if they're not bent to crap, which is what this one is. They're all bent out of shape, but these can grip you right on the surface mount things. But then they'll pop off. They'll pop off very easily. In fact, just moving this thing was enough to pop it off. So, nah, it's strong enough to hold that. It's strong enough to hold that. All right, so we have, let's see, I'm probably going to need like a little perforated prototyping board because we have multiple grounds going into this thing. How would I utilize that though? Because if I clipped a ground with that, then I'd also need, so all right, let me get grounds figured out. It helps to have a solderless breadboard, sorry, that's just there to help you organize things. So that's what this will do. We'll go to this view. I gotta move my one view over here. I'll move the schematic over there just for reference. The schematic is in the Discord, by the way, if you feel like finding it. This is a grody ancient perforated prototyping board. It's probably older than I am. There's a patent number on the back. And I got it from Radio Shack. So anyway, I am just going to use one row of this thing as ground. That's it. Bam. I will need multiple pins to get to ground. And then connecting ground to the 9-volt battery connector is going to be a little difficult. I could desolder stuff and solder it on, but well, like I said, I've been gathering the parts that are in the shop for my entire life. You don't just, well, I guess you can go just buy a shop like this, but there's a lot of little things that you don't get when you do that. Now we're going to be probing with this thing directly, which means I could actually plug in a second probe and have that one go to ground. But since we're kind of looking at like EMF and noise here, we probably want it to be as noise-free as possible. So we'll use this ground probe. You can also, there are these little springs that fit right onto this collar. This little collar, that spring has a little pin that sticks out of it. So you can actually probe RF stuff with a local ground and get very little noise because you have that ground that's right next to where you're probing the pin. I have not needed those ever, not even once. If I was doing more RF stuff, maybe I would at some point need it, but I just haven't. Okay, so power supply at 9 volts. Voltage, 11, 10, 9. 9 volts, activated. Oh, find the probes before they short out on one another. Bother not included, yeah, really. Yeah, really. That's right. So, ground. Now, power we're just going to put directly in. I think we're taking everything as reference to ground, so I don't think we need to go too crazy. Which one is plus and minus on a 9 volt? I think this would be plus, right? Let's just desolder it. Let's just desolder. It'll take 1 second to do. Turn the iron on. Oh, I got the big tip in here, huh? That's gonna get hot pretty quickly. Give me. There's one. There's the other. And I guess I'll solder jumpers onto it. Why not? So I need a positive and a negative, and they need to be rather long. That is not rather long. They don't really need to be rather long. They can be short. I get a little pre-tin on that thing. Yeah, I don't really need to. I'm not going to do that. Minus is the little one, which fits into the big one. So the big one is minus, but we'll just use jumpers. That's minus. Let's get a plus going. That way we can hook everything up sort of remotely. I don't have red. I could use orange, I guess. I don't know how these jumper kits don't have red. Seems silly. That is just way too long. Nope. Where's the one that I found a minute ago? There was an orange. I lost it. I lost it forever. Okay, there's one. I need one more. I need one more, and there it is. Cool. Oh wait, this one is the wrong. This one's entirely. It's all backwards. This bin contains a lot of the special ones that I've like cut up for different purposes. I want just a short little jumper. I can't find it. I can't find anything. What the hell? Come on, man. Well, that one's a little longer, but it's also red. Get these out of the way. I'm trying to free myself up to probe around because we're going to be looking at a lot of different stuff quickly. Although making the battery supply pins short is probably not going to help me out with that. All right, and then go over here and get B plus into B plus. Cool, now we have a power hookup. Got the hookup. Let's get these. Bring them over here. Now we can put ground to ground. And then we can do a power rail over here. And I can just hook. Yellow is going to be for our scope probe. And so red for power. Red or yellow. Get that out of the way. So it's not going to get in our way. Looks like we had it powered on. Heat shrunken jumpers over the DuPont connector type. I don't have a lot of those. I could make a lot of those actually. I've got all the parts, but yeah, I don't have a ton of them. Okay, so a clean setup is very important for probing around a circuit, or for like electronics labs and stuff like that. I advocate being a very, very retentive. Being like extremely clean and organized when you hook up your circuit to the test setup, right? And especially, I've had electronics labs where people have come to me like, my circuit just doesn't work. And I'm like, that's because it's a bird's nest. And I'd go in and I'd clean it up, and then it would start working again. You just got to you want to eliminate all of the little error factors that can propagate their way into your circuit, right? You want to make sure that your setup isn't what's causing the anomalies in your circuit that you're trying to get functioning. Anyway, so we got the scope up, we got this up, we got our voltage at 2 volts, which is a pretty decent voltage to be probing around on a 9-volt circuit board with. We probably need a slightly better close-up view. So we could use the microscope for this. I could also use the four panel view, and then we'd actually be able to take a look at our circuit at the same time. Maybe we'll do that. Because we don't need thermals in here. Okay. And you'll have to excuse the extremely bright light that's right there, because we need that in order to see the circuit board. So, where do we want to look first? Well, the first thing that I want to look at is what is going on with Z1 and C1. So Z1 is the very obvious Zener diode sitting right here. So we reference that to ground, and we get fucking nothing. We get nothing. We get absolutely nothing. Hold on, let me dig in there a little bit. All right, we get a little bit of like an AC offset. We get an offset with a little bit of noise, and that's like 3 volts. 2.9 to 3 volts, and there's a little lump in that. Now, one thing about my setup is that I have, hold on. I have LED lights hooked up to the setup. Problem with these LED light strips, at least the ones that I got, is that they generate quite a bit of RF. So, if I just touch the side of the circuit, it goes psycho. So those little nubs, what happens if I go into my lights, and I turn off the desk light? Okay, nothing. Okay, so that is what's going on there. In some instances, we can get like noise from that. So that's 3 volts with like a little lumpy thing on it. And right now we are detecting up to orange. Red's lighting up too now. Apparently we're in the presence of a shitload of EMF, that or whatever I'm doing in order to probe this is affecting it. That's what's on Z1, huh? That was to be expected, though. That was to be expected, because we were looking at the... Here, I'm going to see if I can move this light back a little bit so you guys aren't totally inundated with it. Actually, I think maybe the desk light we can just turn off. It'll be a little harder. Well, no, that's not that much harder to see. Okay, that's actually much better. Yeah, smartwatch would. Anything that's got a radio in it, man. I'm wearing an insulin pump that should be giving off EMF occasionally. But this thing isn't fully isolated. Like when I connect to this probe, it might affect what this thing is reading, because electricity is running around in the presence of this coil. So if I plug in right there, we get that. That's what's on Z1. So that answers one question. So it is kind of a noisy voltage offset. Be like, That's like 3 volts. Oops. Weird. That's weird. So that's going into everything else, and I guess it must make things look a little weird. Q1, well, at the base of Q1, we'd probably see that little blip get filtered out. So where's Q1? There's Q1, and we're looking at the base of Q1, which is this pin right here, leading over to this right here. So right there. Well, it's still a voltage offset, and I'm seeing, that was just me hooking it up. So it still just looks like noise, just a blippy, noisy thing. Blippy, noisy nonsense. I would have expected to see something a little cooler. What's on the other side of this? It's still a voltage offset. That is definitely the base. Yeah, the collector goes into the antenna, which would probably make this whole device freak out when I connect to it, right? Yeah, it goes psycho. It's actually a lot cleaner on the antenna line. All right, so then what's happening at the base of N3? What we should be seeing is like an increased gain on the signal. Where's N3? Q1, Q2, N5, Q6, Q7, Q4. Where's my transistor? Am I missing a transistor? Q7, Q6, N5, Z1. Oh, that's right. N3, the marking is like way offset. So N3, what is happening on, what is triggering N3? Well, that's our buddy, but it's even smaller of a signal now. It's this tiny little offset. It's a 1 volt offset. Getting smaller and smaller. So what's happening on the collector of N3, because that's what's triggering Q4. Yeah, that's this over here. That's triggering Q4. Even smaller of a signal. Q4. We've got like what's almost starting to resemble a triangle wave, kind of. There's like a little bit more of an offset to our signal. It's sort of going up and down, but here, I'll zoom in on it a little bit here. Yeah, there's our signal. It's like resembling a triangle wave. Sky pair. What? Better for high frequency amplifiers than a Darlington. Okay. Yeah, it's sort of, I mean, we're going for high gain here. What we're trying to do is sort of highlight and amplify that noise so that we can put it into our bar generator, which right now the whole thing is triggered to no end. It's going psycho. All right, so the output of those pairs when they get amplified is right here, right? Hard for me to display this with the way this monitor view is set up. Hold on. Let me make this smaller. I can drag this a little bit. Nope. Drag that like that. And now, actually go down here like this. So the output of Q4 goes into another amplifier, but this one is now connected to 9 volts. So let's take a look at the output of Q4. Q4 right here, and let's see, this is the collector. This is the collector, this is the emitter. So this is the output. Oh, I'm sorry, Q6, not Q4. No, Q4. Wait, that's the base. This is what's triggering Q4. And then this would be the output. No, that's the input. This is the output over here. Output of Q4. Boom. So we got more, we're highlighting just the, that's an AC fault from me touching the board. So yeah, we've got sort of a highlighted, I don't know, lumpy signal here. So what's coming out of the next amplifier pair? Output of Q6. Q6, input, output over here. Wow, look at that. So now we've used 9 volts in order to create this incredibly chaotic AC signal. So you've got an AC triangle wave. And it sits at approximately 3 volts, positive and negative. So we've taken that little bit of noise that we're getting out of the antenna over here, this little tiny bit of noise, and we're amplifying and amplifying and amplifying it until it turns into whatever the hell this thing is, which looks like Boogie from Nightmare Before Christmas. But anyway, so that comes out there, and it goes through this capacitor, and this capacitor should be blocking the AC element. Look at that. Wait, that's not the right capacitor. This is a different capacitor. I think my power supply is really noisy. I think that might be part of it. Hold on, let's look at what the power supply looks like. Yeah, it's coming from the power supply. See that? Why is my power supply doing that? Why is that there? Why is my power supply doing that? It's not that. Is it the... I don't think it's... Maybe it's none of my lights. We might have to do something about my power supply. I had to look because I'm painting my Sally sculpt from that movie. Oh. Yeah, I suppose you're right. The 9-volt will not have noise. All right, let's hook up the 9-volt battery. I don't know where this noise is coming from my power supply. Yeah, there. See, it's totally stable like that. So, man, we built that power supply a long time ago. I probably should clean it out and work on that a little bit. All right, so I need to get positive and negative into this thing. I guess what I could do is just plug in the wires to the board. Man, that sucks. Can't believe my test setup is all noisy. I put a big filter on the lights, but apparently it's not the lights. It might be the fan. It might actually be the fan that's causing that noise. Might be the PWM that controls my fan might be introducing electrical noise into the system. All right, that's a little less chaotic from the LEDs. That noise still exists. Look at that. Wonder where it's coming from. Well, it's a lot cleaner anyway. So this was our triangle wave signal. Here's the other end of it. Oh, no, that's ground. Wait. C6 isn't the one we're looking at. We're looking for C8. C8 is this little one right here. So look at that. We've got like an AC signal running around on there. I wonder if I turn my coupling to AC, what we'll read. But we're in the presence of a DC signal. Look at that. So there's that voltage offset. And then on the other side of the capacitor, no more voltage offset. So now we're just in a DC system. That's why you have capacitors in line with something that's driving a speaker, because the speaker doesn't care about the voltage offset. The voltage offset would just push your speaker out and leave it there. So you put it through a capacitor, and then the speaker can wobble back and forth properly with the magnetic energy changing. Okay, so let's get that on there. So C8 then has R15 and 14 doing some kind of filtering to it. Whoa, that was from me touching the board. Yeah, when I touch the board, I'm inducing an AC wave onto it. Those go to ground. They also go to these two diodes. But that signal is going to look the same for this whole branch. So we're basically just looking at whatever that buffered signal is that goes into the ladder of op amps. There. I need to get it better. I need to push down a little more on it. And of course, if I induce an AC signal, this thing goes psycho and all the lights light up. So over here, this chip is using all these resistors in order to compare one line to the next. So the one line would be here. Not quite. Yeah, one line to the next. And when when I juice it up by touching a part of the circuit over here, you can see that noise going in and getting clipped. So that would be the effect that the diodes are having. The Zener diode and then the buffer diodes are clipping the signal probably at a level that triggers the red LED. They're just buffering and making sure that your signal is good going into the thing. So I think for the most part, our predictions about how the circuit is functioning is exactly right. There might still be some errors in my own personal reverse engineering of the circuit itself, but I think we got the gist of it and we've verified what exactly is happening. We're starting with a voltage offset coming from an antenna over here. That's going to have very small amounts of AC noise on it, depending on how much EMF the antenna is picking up. That gets amplified with a super duper high gain circuit that for some reason is feeding back into itself. I don't know what the hell's going on with that. That offset is just used, I guess, for the initial amplification stages. It then gets amplified with a full 9-volt signal and ends up looking like an AC offset wibbly line. Then that AC element, the DC, is eliminated from it's separated out from the AC so that you just have positive and negative voltage swings on this. It will then be regulated by a half-bridge rectifier so that you still have AC there, but it has limits to how high and low it can go. You can see right there, that's the limit to how high and low it can go. It then gets put into a ladder of comparators that are triggered when their resistor ladder voltage value is equal to, I think it's equal to, I forget what the equation is, equal to or opposite, I fucking forget. That will then trigger the line that lights up the LED. That's it. That's the operation of our device. It is a legitimate EMF detector because it is actually detecting EMF. It's the people who explain what this thing is doing that are the charlatans. Those are the ones that are fooling you. This is at 9 volts. Okay, so that is 9 volt, 0 volt over here. I don't know if these are rail to rail. They're comparators, so I don't think they're doing anything rail to rail. But yeah, it's basically the difference between this and this. And so that is the output over here. Which one is our first LED? G1? That was G1. Huh. Oh, this is the output. The output's positive. The input is slight offset. The other input is no offset. It would be the AC signal that we're getting in. Bada bing. Electronics can be very simple if you know how to break stuff down and you know the structures. Now I want to look up, Pseudomaze had like a overly complicated type of analyzer, or sorry, a type of amplifier circuit that I'm not familiar with. And that's sort of one thing that can kind of slip you up, is if the structures of the circuit are slightly different from what you're familiar with. Because like, you know, just looking up EMF detector, I was scrolling through the data sheet just to see what kind of like application circuits they had. And then I see this thing and I'm like, wait, that's exactly what I found in the circuit with the op amps. So, or sorry, with the comparators. I guess they decided that it was too expensive. Zizli pair. What the fuck? So this would be a way to amplify without using Darlingtons. I guess you're using an NPN and a PNP in order to make a high gain amplifier. You would have one voltage level. Yeah, so I mean that appears to be the structure. I just don't, is there another name for it that I'm familiar with? Complementary feedback pair. Yeah, so I guess the feedback element is important to it. I would just call that a Darlington if I saw that. A shitty LED multimeter, yeah, with an antenna on the end. But it's like super high gain, and it doesn't, you know, a multimeter would have like a full, no, it would have a, crap, what is that called again? Resistor thingy. Why am I forgetting all of my fundamentals today? Is it like a, it says that it's not a Darlington. I know. A Darlington is when you use a small transistor to trigger a large transistor. Comes with age. It's also being on stage. No, what's the set of 4 resistors that these things use in order to determine what something's doing? It's like a I forget. Yeah, Wheatstone bridge. Thank you. A Wheatstone bridge. NP called a complementary Darlington. The configuration is named for George C. Yeah, I couldn't tell. The thought to be inventor. Similar to that of a Darlington pair's product of the current gains of the 2 transistors. Figure above illustrates PNP pair that acts as a single by replacing Q1 with a and Q2 with an pair will act as a overall. Okay, cool. Somewhat like a single transistor, the same type, Q1, current gain, beta. Is that beta? I think this is a different one. The emitter Q2 functions as a collector, hence the emitter of Q2 is labeled C in the figure above. Wheatstone. Yes. You avoid that if your tires are bald. Uh-oh. Yeah, this will be on the test. This will be... Actually, the chapter after this will be on the test, but I'm going to tell you that this is on the test. Typical application, the collector of Q2, also connected to Q1, functions as an emitter and is thus labeled E. As with the Darlington pair, a resistor can be connected between Q2's emitter and base to improve its turn-off time. Oh, I'm super fast turn off. I'm a super fast turn off. 2 sentences in, and I'm out. One advantage of the Darlington pair is that it has the base turn-on voltage is only about 0.6 volts. So, I mean, they're talking about it as a switching element. We're talking about it as an amplifying element. Although I guess what they're doing is they're using them as switches in order to they need to hone in on whatever EMF is making its way into the antenna, and it doesn't need to replicate whatever's coming into the antenna. All it needs to do is detect it. So I guess what they're doing, and I don't know if Q1 and Q2 are necessarily, I guess they are. I flipped Q1 just because it was a little bit more sort of natural looking, because they are sort of like triggering this off of the capacitor, and that sort of pops things off. That starts our whole complementary pair chain. Although, did I get them? No, I didn't get them wrong, because these suddenly flip to 9 volts. So it's these two, and then these two are a slightly different type of circuit. Let's do like RF transistor trigger. To be RF transistor trigger. That's looking a little bit more familiar. That would be a Schmidt trigger, though. Here are the circuits that I would typically find, though. They're amplify, 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 and then you have an LED on the thing. I guess they decided to copy the bar chart chip by putting comparators in there, which maybe that makes it a little bit more stable of a signal. I mean, what it's doing is legit. It's actually legitimately getting data. That's how the AC detecting hot sticks work. I never found use for those. It's just me. Scope trigger, AC generator 4. See, we don't have a 4148 anywhere in the mix here. Yeah, input, V bias. I don't know. I think it's some level of ban. You're banned. Mods ban that guy. Whoever the fuck Dins is banned. Okay, so what I'm looking at is we have an antenna that's going directly into a transistor, and I just want to see what that kind of circuit is. It would be, I mean, I could obviously look up like EMF transistor circuit. Most of the time you're trying to avoid EMF. In this case, we're trying to just amplify it and detect it and turn it into a signal that'll flip an LED on and off. I'm looking specifically just to see what exactly that antenna is doing, what that transistor coming down off of the antenna in a loop with a capacitor is doing. Would it be something like this? No, because we don't have a diode on it. Well, we do have a Zener diode on it, but it's not quite this. ROMv4. What the hell? Suppressor diode. Well, okay, this is how you trigger a relay. Tell Willow I say hi. Tell Willow I say hi before I'm banned. She was visiting a minute ago. I think the door's closed upstairs. She's probably snoozing it up by the front door. But the beginning of stream, if you want to say hi to Willow, you can rewind the stream and you can see her for a brief but a moment. But yeah, she's not going to come back down and visit because she's locked up upstairs. I was sitting here working earlier, trying to put some finalization on some things and go through emails, and she marches downstairs, sits right next to me, and then barks. There's a little humph. And I'm like, she learned the signal finally. What I've been doing is every time she's had to go for a walk, she will sit and stare at you. And I need more of a signal than that because I'm dumb. So what I've been doing is I've been telling her to speak before, and then as soon as she lets out a little humph, we'll go on a walk. So today, after 2 days of doing the speak protocol, she actually responded in kind, and she came over to me and went hemph. And so we went on a walk. It worked out. I'm teaching the puppy things. That's not what I want there. Atlakut. Thank you for subbing with a Prime. Hey, there's a something Prime commercial. It's just every time. If you have Amazon Prime, you have a free subscription to the streamer of your choice. It doesn't have to be me, but you should use that because otherwise it's just like $5 that just kind of festers. Well, $2.50 that just kind of festers. So you use it on your streamer. Yeah. There's no real reminder. You don't get like an email reminder. Twitch will tell you when you log into Twitch that your sub is lapsed, and then you have to go through and sub again and check the little box that says use my Prime. But yeah, it's a free subscription. You should take advantage of that. I'm not seeing the circuit that I wanted to. Not quite seeing the circuit that I wanted to. We saw some stuff that was very similar up above when I was perusing circuits. Things like, not that one. Kind of like this, kind of. But the diode is across the coil. That's not across the whole. See, this is how to switch an inductive load and have the flyback current go away. That's what that diode is doing. That's this. So you have a transistor switch, you have an inductive load, and then when you unswitch that transistor, you have a very strong opposing voltage in there created by the dissipation of the magnetic field. And so this is one method of creating higher voltages, is to trigger that a bunch and then capture it in a capacitor. However, if you're not trying to capture that voltage spike, you need to dissipate it. And so you do that with a diode facing in the opposite direction of the voltage here, so that in normal operation, this thing isn't doing anything. It's just blocking the reverse current. When you unswitch this transistor and the magnetic field inside of the coil dissipates, that opposing loop will go through the diode and dissipate out, and it'll keep your I've seen transistors die in like a matter of like a day when they're used in this manner without the diode. But that, I don't know why I'm getting so many flyback diode circuits on this search. EMF transistor. I guess they're calling that electromagnetic interference. I don't know. One of the circuits in here looked a lot like what we were looking at, but it had some other stuff on it that wasn't quite what I was looking for. Anyway, simple metal detector. Don't mind if I do. That's kind of similar. It's kind of similar. We're not really a metal detector though. We're looking at EMF. So the question is, what frequencies is this? It would have been nice if we found like a thing that specifically detailed the operation of that type of circuit. Back EMF, yeah. I need a bacchiotomy. A backectomy. A bactoplasy. So, noisy voltage offset. These are amplifiers. This thing is a buffer limiter. Well, DC kill. Where were you in DC kill? No. And then this is a buffer. Limiter. And this would be just a compare. It's just like, I don't know, comparator or just bar graph. And this just seems like it's a voltage offset. It's not really doing anything. It's just a V offset. And it's not noisy. We discovered that it's not noisy. It is a little noisy just because of my shop. But so that ghost line is not really a ghost line, which means the green LED is very simply just triggered off of voltage. So this is just a battery indicator. Quote, bat slash power, end quote. Pro MS Paint skills. The thing about like making text legible in MS Paint is to slow down. There's no way to get around. You just got to slow down. You just got to slow down. I broke down, and since I was sketching the circuit all with the mouse, it started to like, it was like instead of these being straight lines, they were like an arc. So I kind of broke down and went, you know what? I'm gonna go ahead and use the line tool. And so I drew up all the signals that I would need, and just cut paste them into the rest of the thing. Oops, wait. That's what the ghosts are after it kills the DC. I've done pro schematics in pixel art scale on this, on MS Paint. I mean, like, schematics are meant to be sketched, you know? You can get CAD programs that help you put all the schematics down like this, but they all have their own particular style to them. The one that I would love to use is CirCAD, but is that CirCAD? I think so. But the problem is it doesn't look good until you print it out. So WRXing it up. Hey, thank you for the Prime. That's a third month of WRXing it. Appreciate that. It's very kind of you. Very kind indeed. Okay, so we know what the circuit is doing. It's just simply like amplifying some kind of a wibbly signal on the coil. Let's measure the coil and see what frequency it likes to respond to. Although it is it's a coil and not an antenna, but it is kind of an antenna. It's more of a coil because it's got a voltage offset on one end. That's weird, right? I don't know. What good is measuring it going to do us? Well, let's try to get an idea. Let's just do it because. Whoa. Let's just do it because. I gotta fix my thermals are constantly undoing themselves from the camera. Maybe I should use magnets on it. You think magnets would interfere with thermals? Also, what does this thing do in the presence of magnets? I would think that if you have a magnetic field passing in the presence of a coil, yep, 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 I see that. I see that. It's a ghost. It's definitely a ghost. We got ghosts. We got ghosts. We got ghosts here. Definitely ghosts. Not an entirely useless piece of equipment. It is definitely detecting magnetic interference. I don't know how much I would trust that it is detecting magnetic interference, but look, if the magnetic field is stationary in the presence of the coil, nothing happens. But as soon as you start moving it, and the severity of how much you move it, it will detect it because we're inducing a current in that line. We induce a current in that line, and then that line amplifies it and amplifies it and amplifies it, and then it defeats the DC component and puts a signal that looks like this into the rest of, well, into the bar graph generator. See that? You can barely see the, okay, I need to like somehow isolate out all the stuff that I'm blocking the view of. That first LED is completely and entirely useless, by the way. First LED doesn't do a thing. It don't do nothing. So, magnet, move it. We get spikes and stuff. Don't you try to justify that in ghost terms. Don't put that evil on me. I want to adjust, not horizontal. Center it on horizontal. I want to move this up because we're swinging positive and negative here. See? So it's limited to 2 volts negative. It's limited to negative 2 volts, and it can go up to positive 4. Negative 2 to positive 4. And that would be the reason, I guess, that these lights are flicking back and forth. Crazy stuff, right? Pretty cool. Then again, the comparators are only using 9-volt output, so I guess it doesn't, I don't know, swing to like an offset. Either way, I mean, it'll detect a magnetic field or an RF signal, I suppose. If you're really like sort of out for lunch trying to figure out where an RF signal is, you could use this thing. You're not exactly going to be categorizing anything accurate. This is literally just like a student project circuit. This is like something that you'd build like as a high schooler. With a little bit more complexity. The button turns it on and off. Here's what the button does. Whoa, so many ghosts. I guess that capacitor is probably responsible for that response when it turns on, where all the LEDs light up for a brief amount of time. Then when you turn it off, yeah, nothing happens. Turn it on, that circuit is sunk to 0, and so all of the comparison stuff and everything else goes off until all the capacitors charge up, and then everybody turns back off until they're triggered again. Yeah, even with a magnet, you set it off all over the place. Oh, I'm not even on the probe anymore. Cool stuff. Well, for 20 bucks, I got 3 streams out of the thing, and I think it was pretty interesting. We got to partially debunk what the hell ghost hunters are all on about. I think for that fellow who says that his brother's going on a ghost hunt, you should sneak a magnet into his pocket. You put a magnet in his pocket. Just put a little rare earth magnet on his hand or something. Because that will cause all kinds of chaos. Move the PCB, magnet is stationary? I mean, that's just going to do the same exact thing. Here, look. It's literally this is like Einstein, like frame of reference. Like, imagine the universe moving instead of your magnet. Drop magnets randomly around the house. And you could probably use like a white noise generator and like a ranged, like a wide range antenna, and just blast the place with RF every now and then. It's not detecting ghosts. We've determined exactly what it detects. And what it is looking for is magnetic energy in the form of electromagnetism or radio frequency or a fixed magnet in the presence of a coil. That's it. It's an RF detector, RF and other electromagnetic phenomenon that aren't ghosts, that ghosts don't control. I'm in control. I control the vertical and the horizontal. Look, see? I'm a ghost. Oh my God, there's a ghost over here. But if we have a magnetic field that doesn't change in the presence of our device, nothing happens. There's nothing to amplify. There's no induced current in our coil. If we induce a current in the coil by moving this slightly, then we get a response. Pretty cool. And we can measure that response because this is a physical object that has actual properties, and we can probe in on exactly what the signal is that they are exploiting. There we go. We can even see it over here on the coil. Boop. So there is a voltage offset induced. If I move this around, you can see almost nothing is happening. So that's what we need to amplify. We put it through a bunch of these wackadoodle transistor amplifiers that I'd only heard of just now. Pseudomaze is the one that knew the name of them. They amplify it up, then they put it into one side of a capacitor, which eliminates that DC offset. That signal is then basically compressed. It's kept in a range, and it goes into our voltage detecting ladder. And so the way that's configured lights up the LEDs as that voltage changes. So there we go. That's it. That's all it does. You have a name, Science. You have science in your name. Stop misrepresenting. Bada bing. That's it. Easy peasy. Now, oh, hold on. I'm being followed by ghosts. The reason that we were able to determine all of... Whoa, 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 whoa. Sorry. My, my power supply is ghosts. The tips of these two connected, and I should have known that the fans were going crazy. But thermally, we can see that these wires are heating up because they shorted out. This thing has short protection, but I guess it wasn't doing too much. Jeez. They're like warm to the touch. Yikes. Yikers. We really came to that conclusion in an hour? That sucks. It sucks being good at what you're doing. Fuck. That's way too easy. Well, let's see if we can see what this thing is. I mean, it's a coil, so it is sensitive to magnetic energy. I don't know if it's working as an antenna so much. Like, what if we put it in the presence of Wi-Fi? Hold on, let me go on Discord. Actually, just simply opening Discord would probably be enough to get Wi-Fi energy. Nothing. It's not that sensitive. Let's go to stream projects, and I'm going to transmit 1, 2, 3, 4. I'm going to transmit it like this. Oops, like this. Oops, like this. Oops, like this. There we go. No, nothing. It only lit up because I touched it. Well, I mean, it's an electric field detector. Like, this isn't doing anything. It really is just like a magnet and maybe noise detector, but it needs a pretty strong signal to come up with anything measurable. I'm looking around. I'm seeing what I got. Let's use this. That was a very powerful magnet that I put in its presence. This is a slightly less powerful magnet, but it's also still a magnet. If I put it on the end of the screwdriver, then I can wave it around a little bit more. Yeah, it's... Most notably triggered by a magnetic field. What do I have that generates a lot of RF noise? I don't really have my... Oh, maybe the RC car remote. Let's see if that frequency gets a response. Cell phone wasn't registering on this. It's a very unsensitive device. I guess my electric fan over here would do that too. All right, let's see. RC remote. I think this thing is 2.4 gigahertz. It might be 5. What is this one? What is this? Oh, it's actually a spread frequency, isn't it? I'm not sure, but let's find out. I gotta get my mic cable untangled. All right, let's try this thing. How do I turn this thing on? Oh, yeah. Yeah, if an antenna barely registers on this thing, it is a very unsensitive device. Look at that. You barely get anything from this. Because this is sending out a digital signal, but it's very, very I don't know how else to describe that. Interesting. Well, I think you categorized this thing enough. The question is, do I put it back together? We should hook this up to chat, and I could have a ghost event that you guys can trigger with channel points that'll turn on and off all of my lights and make this thing dance all over the place. Is this the same type of device they used in like the 50s to find electronic bugs? Probably. I don't know. I mean, in the presence of 1950s radio frequency devices, yeah, this thing would probably go nuts. But as far as I'm concerned, this thing just acts like a coil. Put it back together, or you can fix it. Well, so the operation here is that we have a coil of a particular length, and when you've got a trace that's a particular length, that's going to be sensitive to a particular frequency of AC, of RF, of radio frequency. We can calculate that. So let me get the calipers out. And I'm just going to measure this antenna, and we'll see how big it is. We'll see if we can figure out what it's sensitive to. There's a lot of real estate to go through on this thing, so I'm not going to spend a month making this thing more simple. That's silly. All right. I guess we can stay in this view. I got to turn this light on over here. There we go. Now I can see. Ow, poked myself with my calipers. Probably not going to be an even number, is it? So 53. I want to say 51, but that's like 0.38. I got to make sure that this is on the right spot. 51. It's like 50, 51. Sorry, 50, 52, 53. Yeah. 50, 52, 53. Hold on, I'm going to add all these up. So I'm going to open up a browser window and just like type the numbers in. 50 plus 50. Hold on, was it 5123? I think it was. That's 50, really. Can't say that that's 51. $50, 51, 53. Wait, there's 4. There's 3 on the other side. Hold on a minute. I'm going stupid. Oh, I see what it is. It's okay, so it's 50. I'm measuring it diagonally because I was messing it up. So 51, 52, 53. Okay. 51, 52, 53. We've got this little length right here. And this is going to be like a loose count, but 32. Then we're going to go do these over here. Because yeah, these are different on the one side. So that's going to be 43. Hold on, I got to position the calibers. 43, 42, 41, 40, huh? Plus 43, 42, 41. Uh-oh, lost it. Ah, crap. 3, 42, 41, 40, 32. So far, we've got 351 millimeters on our thing. Tiny speaker displays a Ghostbusters theme when it gets high enough of a signal. You would just trigger it off of the last LED. That's an easy one. Okay, so we got the 32 in there. We got all that stuff. Now we do this one. This one's going to be more varied, and I'll get it before it goes that weird 90-degree angle. It's like they're avoiding stuff in the circuit by spreading it out here, and I don't know what effect that's going to have on the RF. Probably unpredictability. 50. $48. 50, 48, 45. Okay, I gotta start 50, 48, 45. The last one, I'm gonna forget these. 41. That was a double. Nope, that wasn't a double plus sign. 41. Okay. Now for the crazy town, where everything is going all different directions. So I have 4. And 13. 4 and 13. Next. Now CAD software could do this for you, but we don't have this in CAD. 16 plus 3 plus 3. 16, 17, 19, 20, 21. Wait. 22. 25. 25 plus 24. Jesus. Plus 25 plus 24. That's that trace. Then we have 15. 6. No. 15, 5. 15, 5, 4. 15, 5, 4, 3. 15 plus 15 plus 5 plus 4 plus 3. I'm making a computer add this up for me. 23. 23. Why is that stuck? Oh, there's a magnet on my caliper. Get off my caliper, you stupid magnet. Oh, they did not use good stainless steel on these. All right. Then we do last one. This is the last one. 18. Not 10. It's got to be. It's like less than 10. I don't want to add fractions. Fine. 18, 9, 4. 18, 9, 4. 17. For a grand total of 699. Brillenshuker, hey, thank you for the prime. Brillenshuker's been primed for 32 months. It's awesome, dude. Thank you. 699 millimeters for the antenna. It's probably 700. I'm willing to give it that millimeter. I was rounding everything to the nearest millimeter and not measuring it totally, completely accurately. CAD program, of course, you can just measure the length of the trace and it'll tell you. But so anyway, we can either remember our homework or I could just put this into an online calculator and just get the number. So antenna calculator. I mean, this is more of a choke because it's in a spiral, but whatever. Let's see what the wavelength is on this thing. No, I want a distance. Frequency, C over lambda, lambda over C. No, I'm looking at antenna. I want full wave. CB is approximately, wait, what are you talking about? 11 millimeter. What are you talking about? 428 megahertz? Wavelength is 350 millimeter. That's not what I put in. They just put a number in there. All right, we need a better one. This is for a dipole. We're not interested in dipoles. Ground plane antenna, I guess. Although no, not really. Frequency. I could do antenna length too. Always trust in Java applets. Not this one again. Full wave wavelength, 700 millimeter. Nope. Don't do that. Well, this is still giving me 428 megahertz, so maybe that is what it is. Half wave, just gonna be half of that, or double that. So 420 megahertz. That I believe is what they use for. Is that security system? That's like older control. Like you would buy like an RF module back in the day. Yeah, and it would be 433 megahertz, that's an interesting choice. So you can find, yeah, just below amateur radio. 433 megahertz. See that? They're all over the place. There's sort of like the consumer, yeah, like remotes, like it's possible if you have an older car that you're going to have a 433 megahertz remote in your pocket. All kinds of stuff use it, and especially in like home stuff. And yeah, 433 is stuff jumping all around. So this thing would primarily be measuring just like, like if you have a wireless doorbell, like your wireless doorbell, this thing's going to measure it. Frequency or consumer. The consumer frequency spectrum. Actually, it's a fairly complicated affair to know what everybody's doing on the RF spectrum. But in America, and I guess elsewise, we have regulated these things to within an inch of their life. I can't even read that. I got a headache for some reason. I might be dehydrated. Or it could be the glucose levels actually doing that to me. Can I get like a... No, I don't want all this crap. Get out of here. I want like a full resolution. Oh, here we go. Perfect. Yes! So as you can see here, they don't really do much. I mean, I guess if you sell a product, they might do something to you. But generally, the way the FCC deals with new allocations of frequencies is they will monitor them very heavily, and the punishments will be absolutely severe for a little while, and then they're just not, they don't exist. But if you mess it up bad enough to get them out there, you're going to get your ass kicked. 30 megahertz, we're talking about 433, so here we are at 300. Oh, we jumped over to 600. 450, 400. So we calculated that this thing is sensitive to stuff that's just below. Where was that calculation? I mean, 700 millimeters, give or take, right? Because that was a very rough estimate that I did. But 428 is close enough to 433. And if we're at 428 with our... Hold on a minute. Wait a minute. Wait a minute. Wait a minute. So close, physics. You got so close. You got so close. With 713. 69, 420. We got so close. I think this is as close as you're going to get to 69, 420 in the physics of radio. Damn it. We got so close. So 428. Radio location and amateur radio frequencies. All the way up to 450. So 433 is right smack dab in there. That's it. That's what you got. And you know what? Like, this is a good frequency to pick if you're going to be tuning this antenna to be a particular length without it being totally obvious. Now they put it in a coil that makes it sensitive to magnetic energy as well. So Amateur portion of the spectrum shared access session. Yeah. Remember my dad telling me that in the 70s, the FCC would send people in cars driving slow listening. Yeah, that was when, like, you know, ham radio and radio broadcast was like kind of a big thing, right? Everybody was listening. Well, the 70s, you know, everybody was listening, and they had equipment that could then pinpoint, or rather triangulate loosely, where the signals were coming from, and pirate radio became a big thing back then, especially in the 70s. This consumer electronics started to be able to rival the powers of larger transmission, so you could reach more than just a whole neighborhood with your devices. And so the FCC went out and, you know, laid the smackdown on a lot of those amateur, unlicensed ham and pirate radio stations. So yeah, that's interesting. So they chose the amateur spectrum. They probably would have been better choosing like a cell phone spectrum, but I have somewhere in here, I think I have stuff that's 433. Do I have anything like readily available that's 433? What about that dog collar shocker thing? Luckily, we're never gonna need that for the dog. She's too well behaved. Too well behaved. Every now and then she gets a little loud barking, but that's not a big deal. That doesn't garner the use of a shock collar. I bought this on the Amazon deal day, so this is like just for fun, just to take apart on stream. I am not going to hook that up to some kind of like a game where if I lose, I get shocked, because that's against Twitch rules. And while a lot of people can do stuff that's against Twitch rules, I also just don't like getting shocked. What frequency are we? I have no fucking clue. It's not written on this thing anywhere. All right, let's look it up. Dog care shock collar. Rechargeable, that's great. Now I get even more shocking out of my dog. I have a friend with a border collie that actually did use something like this to great effect. He, of course, tried it out on himself, and these have different levels, right? Depending on how bad your dog is. Dogs, remember, are not people, and they can get sort of singularly minded on something that they're trying to do. And if you want to break them off of that, you have to use means that seem inhumane to us, like, for instance, physical means to get the dog to snap out of what they're doing and pay attention to you. So I don't use stuff like this, but my friend has simply, like, if his dog is being a little bit too barky in the presence of new people, he can grab the shock collar and put it on the table, and the dog will listen. So I don't know. We didn't use it, but it was to great effect with him. He hasn't needed it in years. Beat, vibration, blah, blah, blah. They're not talking about the frequency that this thing talks in. It is. Oh, you did the FCC ID. You guys have like a hair trigger for opening up the FCC page. It was like the first thing, and then you go and do that. Let's agree to disagree. All right. You could disagree. Shenzhen Dog Care Innovation Technology Co. Limited. I can tell you right now that we're never going to be using this on our dog. We don't need to. He's very well behaved. So where is it? Somewhere in this document? Frequency range, 433.5. Rules 15B. Okay, so this thing does do like a handshake with the base station. So maybe we need to power both of these on. I don't know what state these are in. I know that if we had to use this thing on the dog, I would definitely wear it and use it on myself just to see what it is. Because yeah, there's beep and vibrate. Yeah. And if the dog is, you know, I would rather shock my dog than have a dead dog. So there are situations where the dog is in danger and you need to be able to quick get their attention and make them stop. All right, so let's see here. Well, I haven't turned this thing on in like 2 years. Let's just see if it turns on at all. It doesn't turn on. It doesn't even turn on. What about this thing? That's the lock. What's your power button? Oh yeah. Oh my god. Yeah, low battery. Let's get this thing powered. Bada bing. So. No, this one's rechargeable. Bada bing. Look at that. So you saw the RC remote, we got barely anything out of it. And now with this 433 megahertz device, we get all kinds of movement from the antenna because the antenna is picking up 433 megahertz. I very haphazardly measured the length of the antenna, and we put that into a frequency calculator that then gives us the level of output, or the frequency that it's sensitive to. Not level of output. What am I talking about? I'm looking for the level of output right now. So yeah, here's our amplified signal right here. Things are calm. Then things are not calm. Hello? There you go. Look at that. Coming in there very quickly. Let me put the time scale up a little bit here. Why? Why are you so slow? Yeah, that'll respond a little quicker. I mean, this is similar to what you do if you just wanted to receive an RF signal. But yeah, there are tons of 433 megahertz devices out there. So having your EMF detector that you don't specify any specifications on, having it be sensitive to 433 megahertz is a smart move because somebody's going to find that interference somewhere. Could I use this to capture the handshake? It's possible, actually. Yeah, it is possible that I could use that. I don't know about that initial uptake from the antenna. What it's doing with that initial data. Let's see if we can find something that looks like a digital signal in here. If I just crunch this thing down, well, actually, the time scale is going to be kind of annoying to capture. Look at that. Yeah, that's our 433 megahertz signal. We could use that in order to determine what it's saying. Right there. Although that might be split up, those might be individual packets, and the system might not be able to respond fast enough to all that individual data coming through. Yeah, I have a feeling that those break down into individual packets. There's a vibrate signal. So I think there's probably digital information available on this thing from the packet, but I don't know. I'm gonna put this thing away and never use it again. That's cool though. We got to be able to see a 433 megahertz device speak with an antenna that's similarly sized. Yeah. And it detects magnets. What, make the ghost hunting device actually shock you? Maybe. Maybe I could do that. This thing is totally dead. Enough of that. Enough of that. Enough of that. I just keep that up on the top shelf just in case I get a little too rowdy. I think we've like closed the door on this thing. That worked way too well, way too quickly. I didn't expect that to like perfectly display the device in all of its glory. We know exactly what it is now and how exactly it functions. It's basically making an offset voltage that it puts through the coil that then has a very sensitive, I guess, transistor to trigger it that goes through a bunch of very high gain amplification. It then blocks out the DC, limits the voltage of that amplified signal, and then puts it into a comparator ladder that lights up the LEDs. We measured the length of the coil. Because it's in a coil, it actually responds to a magnetic field because of the right-hand rule and the gang sign for electrical engineers. Because it's in a coil, it responds to magnetic energy very readily. very readily. So I can just take a magnet, and I got plenty of magnets just sitting here, very weak magnet, and I can move it around, it'll make a little bit of a signal. Or I can make a very strong, or take a very strong magnet, rare earth magnets, and I can wave them, and there's a magnetic field and a coil, a dissipating magnetic field in the presence of a coil. Faster it goes, more current I induce, the higher that level goes. Or I can take a 433 megahertz device, due to the length of the wire acting as an antenna, and I can cause interference on that frequency. 433 being a consumer RF band. Sometimes you don't even know. Something could be transmitting on 433 without you even knowing, like your camera equipment. Or, well, cell phones don't have I don't think cell phones have a 433 megahertz radio in them. But yeah, what is Bluetooth is 2. Isn't Bluetooth, hold on, Bluetooth frequency. Because we put my cell phone up to it and it wasn't doing anything. 2.45 gigahertz is Bluetooth. So this thing is a little bit more rudimentary than that. Yeah, we're not dealing with gigahertz. We're dealing with megahertz level. This is like, I don't know. This is like 1990s level of tech. Yeah, NFCs could possibly also. You'd need the thing looking for the NFC. I guess that would be the phone looking for the NFC. Yeah, garage doors use this. That's the one I was trying to think of. Garage doors, your keys, your wireless keys for your car. Not modern ones, older ones. Yeah, apparently that's the spectrum for ghosts. Basically what you're trying to do is you're trying to get into a frequency that is inexpensive to build around, like build your hardware around, is so common that you're going to see it everywhere and your application has a wide spread and is, well, that's it. I mean, those are the two. You want to be able to design for that frequency and you want it to be prevalent enough that it's going to be something that you would use. And then that ends up being perfect for ghost hunters because there's all kinds of devices that use 433 megahertz. They could be anywhere. They could be behind you right now and you wouldn't even know it. You wouldn't even know it. You wouldn't even know it. I'm gonna shock you, chat. Got him. Got him. But yeah, 433 is pretty widely used spectrum. It's pretty dirty. I don't know. I mean, all the devices using it are going to be using a very slow and rudimentary method of RF communications. So it's very easy for something like, you know, any old remote. Where are my keys? Let me see if my keys do anything. I end up unlocking my car. You guys will end up copying my key and breaking into my car. Joke's on you. There's so many problems with it. You'll actually be financially unstable as a result. All right, my keys use a slightly different frequency. Now my trunk's open. My keys are weak. It's too late. I already live in your car. No, it's an electrical gremlin. Get him out. Get him out of there. This went way too smoothly today, guys. I thought I'd still be completely rusty with my RF electronics, but it turns out we blew this thing out of the park like immediately. There was no drama in that. It just like quite quickly became resolvable. I mean, after getting the schematic, and I still don't know if the schematic is 100% correct. There could be some weird, I had some weird stuff from when we were doing it live, and I just kind of rolled it into a sort of a form that is mostly that makes sense to me, right? So I guess that's how it works, though. And then we characterized and tested it in an hour. I mean, that was ridiculous. So we know what it's sensitive to. So if you are out ghost hunting, you can throw magnets around, or you can take a little wireless like doorbell or wireless alarm system and just boop, or one of those really powerful ones that they have where you have a little antenna that pulls out and you can unlock your car from like a county away. You could just have that in your pocket and press the button, and the ghost alarm, and the guy would be like, "There's a ghost here." And you're like, "Yeah, there's a ghost in my ass." My ace. So yeah, that's it. It's just 433. Unfortunately, a 420 millimeter antenna is not 699, or sorry, a 699 millimeter antenna is not 420 megahertz. And I think that's generally like, I mean, we got to blame the scientific community for that one, because that they dropped the ball there. The fact that a 699 millimeter antenna isn't 420 megahertz, I don't think we'll ever live that one down. Wonder if doing that in a crowded parking lot would unlock multiple cars. No, because there's so many codes that it's like impossible. Don't get me started on key lock. I know a lot about key lock. Keeloq. It's 2 lines of code that exist on a PIC microcontroller that scramble the remote signal from a car. You have a secret key that the manufacturer knows, and then you have an individual key for your key in car. Those get basically go through 256 rounds of encryption, and then when it does that again on the other side, it gets a signal out. In addition to that, there's a part of the code that is a sort of like a circular block, and when you're on one part of the circle, because it counts up every time you try to open your car, it'll count up by 1. There is a portion of that circle where you have to hit the remote again in order to get it to accept. If you're in the wrong part of that circle, it will just simply not accept your code. And so that keeps, like, if you're on vacation and you press your car keys like constantly, you might get home and not be able to unlock it. And that was one of the attack vectors of keylock, is you get them into that portion where it's going to ignore the code number, and then they could sit there and press the button for the next 6 years and they still wouldn't unlock their car. Horrible stuff, but that's keylock. And keylock sold, the guy came up with keylock encryption. It takes 2 lines of microcontroller code, and he got $1 million for it. Could you imagine just getting $1 million and then having every car company in the world use your scheme for their wireless remotes? Mind-boggling is what that is. Anyway, so, okay. How does the ghost detector work, Bother? What the hell is this thing? Okay, so we got a couple different parts about this circuit, and my diagram might not explain it incredibly well. We start with 9 volts, right? So upper left-hand corner of the schematic. That's the parlance that I use. All of the power stuff is going to be in the upper left, and then the function goes left to right, hopefully up to down, although we're not really seeing that as much with this one because of the way I organized it. First things first, once 9 volts hits your circuit, we need a voltage offset that's going to power a bunch of the stuff going on. So the voltage offset that we're going to have is going to come through this 9-volt battery, through the 4.3 kilo ohm resistor, I guess working as a current limiting device. It's going to come down through the capacitor and charge it up. So as that capacitor charges up, this thing is at 0 volts, this LED lights up initially. Also, since we are just trickling current into here, the comparators are seeing nothing and comparing it to nothing, and I guess activating or something. Or maybe the micro voltage levels. Somehow that lines up, and so all of the LEDs light up in the same manner when this thing boots up. As the system boots up, this capacitor is going to charge. We've got a 3.3 kilo ohm resistor sitting there doing God knows what. I don't even know. We end up with a voltage offset here, about a 3-volt voltage offset sitting on the top of the coil. That coil, when energized with magnetic energy, will end up triggering the PNP transistor Q1, and we will have a very weak signal right here at R1 and C3. R1 and C3 are going to filter out some of the transients and stuff. We will then trigger Q2, which is another PNP, with the negative part of our wave. Our negative part of the wave goes through Q2 and N3, which is a complementary pair that works similar to a Darlington, but not really. They sort of make a high gain, quick high gain amplifier. So that goes through first stage of amplification. It comes out here to N3 and Q4 and N5. No, wait a minute. Something happens here and we get a signal on the end, and then that gets amplified by this circuit right here. So we're using that offset voltage, which also has the noise on it. I don't know. And that will then amplify with N3 and Q4. We get an output signal here. We need to amplify it more. It's still not enough to trigger our ladder of comparators. So what we do is we hook it up to 9 volts instead of the offset, and we put it through another one of these sort of high-speed Darlington-esque circuits that involves an NPN and a PNP. We then kill the DC component. And since we've murdered something, that's where the ghosts come in, right? So the ghosts are here on this line. The DC component has been eliminated, and now over zero voltage, we've got this noisy signal of whatever the hell's going on 433 megahertz. I'm not going to write that down. So whatever that noise is on 433 megahertz, it goes through whatever the hell this fucking thing is right here. What this is a diode facing one direction, diode facing the other. Since our signal is wavering around 0 volts, one diode is going to activate in the reverse direction, the other diode is going to activate in the forward direction. What that does is that limits the overall size of that wave so that we can't overwhelm any of the electronics on this side of the circuit. So it's just a little bit of a safety precaution. 100 kilo ohm resistor is sitting here as a means by which to make sure that your LEDs turn off when there's no signal. Otherwise, residual current in this line can tend to linger, especially when you have a capacitor going into it like that. Residual current in the line can linger, and so the 100 kilo ohm resistor is there simply to dissipate it. 100 kilo ohms is a lot of ohms for a 2 volt signal. This is basically 2 volt here and what was it? It was like 4 volts and then negative 2 volts. It's limited to. That's the effect of these 2 diodes. So it wibbles between 4 volts and negative 2 volts depending on the strength of the 433 megahertz signal that goes into that coil, and then it illuminates depending on how many of these it can get through. So compared to whatever the heck this partial voltage level is doing through these resistors. So the most sensitive one, I guess, is here, and the least sensitive one is down here. No, sorry, I have them backwards. So this would be the least sensitive one for some reason. I guess maybe because it's more of an offset from the two voltages. But what that does is that makes these flicker and turn on in sequence depending on the strength of the RF signal going in. Since we've put this antenna in a coil, if there is a magnetic field present within the range of that coil, because of, again, the right-hand rule, the electrical engineering gang sign, as well as, what is it, is it left hand, the Lorentz force, and then the things with the coils and the induction. When you have a coil and it's in the presence of a magnetic field, a difference in that magnetic field will induce a current in the coil. So if you put a magnet next to this coil and you don't move it, nothing changes. It just, your meter is reading nothing. But if you move that magnet, the change in that magnetic field is going to induce a current, and then that current gets amplified and put into our bar chart. So you can walk by your buddy with a ghost hunting EMF detector, and you can actually trigger their machine if you get a magnet close enough. But magnetic energy is like exponential. You have to get pretty close. You have to basically touch it with a magnet. If you have a 433 megahertz device, though, which is a common consumer device frequency for a lot of different things, if you have like a little remote or an RF remote for something, it's likely that it will be 433 megahertz, unless it's Wi-Fi. But generally 433 is where most of your consumer electronics are going to sit. So I found this thing from Amazon Deal Day, which was a dog shock collar that I'm never going to use on my dog. We don't need it. And we don't have situations where we've worked very hard on recall, so I don't need this unless she decides to bark infinitely, in which case I'll have to reconsider my position on it. But anyway, I have this thing because it was a funny thing to take apart for what was it, Amazon Day or whatever. Funny thing to take apart. I didn't shock myself with it because I'm wearing a lot of electronics. I'm wearing a lot of kind of voltage sensitive electronics. But if we put this up to the ghost detector, I'll just do that. How do you turn this thing on again? Oh yeah, that's right, the thing on the top. It acts like it's a radio. I guess that's the volume of the feedback you get. But you can see it's driving the thing absolutely nuts. Here, wait. It's too quick to pick up. There we go. It drives it absolutely nuts, and we get this weird signal coming out of it because that thing is sensitive to 433 megahertz. But again, you have to get pretty close because look, I'm not that far away, and it's not really triggering it. You get some activity, But really, to set off the higher levels, this is such a rudimentary device that you need to get really close. Oh, apparently more is coming out of the back of the device than anything. Oh, are we on the same plane as the antenna? That's what it is. Look at that. So nothing, and then when I'm on the same plane, it's triggering it quite a bit more. So if your friend is holding the ghost device up like this, you'll have to hold your device sort of in the same vector. Like it can't go perpendicular to the antenna. So you got to think about how that antenna's in there. Yeah, see, I have to be within, what is it, 1, 2, 3, 4, 5, 6, 7 inches is about the limit for this device. Now you could do stuff to focus the RF sort of towards the ghost hunting device, but oh yeah, and then finally that voltage offset right here, it's just turning this transistor on and off, which turns on the first green light. So this light right here is just like a battery indicator. There's really nothing to it. Nothing to that. So, oh man, it pains me that I'm at a really nice number of people watching, and I appreciate you guys coming out. I don't want to prolong the stream if I don't have anything to do. I would like to try to bend some tubes. That's one thing. Something I wanted to do is bend tubes, but I don't think that's gonna. I think that's gonna take us more than like at what, 2 hours? I think because we're really gonna want to get it right. I basically need to pinch one end of the tube, fill it with water. Or sorry, pinch one end of the tube, solder it closed, fill it with water, pinch the other end closed, and then solder that. Then we can try to bend it around a form so it won't kink. Take apart the dog collar? We already did. We did that, didn't we? Yeah, we did that. We've already done that. I don't even know how I'd get into this thing. Where's the collar part? I threw the collar part across the shop. It was a good thing I had this just to be able to... Oh, you know what? Maybe I didn't put the battery back into this thing. Maybe that's why it doesn't work. Just to be able to hit some 433 megahertz out. I don't know. This thing does two-way communication. It tells you what the battery level is and stuff, and you can just beep it. It can just beep. Boop, boop, boop. Beep, beep, beep. What? Oh, yeah. Wait a minute. How do you... No. Yeah, there's a vibrate and a beep, but then there's also like a power level thing on it. How do you access that? I don't know. Oh, hold down for level. There we go. Okay. Nothing's happening. Nothing is happening. No. I think maybe it needs to communicate with the other device to do a power level. Oh, I forgot about that. Apparently that's a digital encoder. Yeah, you hold it down and then you can... So we were at the highest power level. What does the lowest power level look like? That's the same signal. Yeah, it's the same thing. Now, you guys aren't able to see because you're viewing this in 60 hertz, but these are going psycho. Like, they're flashing quite a bit. It doesn't look like... You guys just see it, like, fading in and out over here. They're actually completely flashing. Like, boop, 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 boop. Like that. You're just missing it. Yeah, it's just a different number on the number line. We could... I mean, 99 should be FF, which actually could mean that the signal is more... flat. I don't know, whatever. Anyway, that's the ghost hunting device. It's a 433 megahertz and magnetic energy detector. Somewhat, I would say, passive detector. But, you know, it's not ghosts. You're not detecting ghosts. You're just detecting very, very small voltages that can be induced wirelessly. No, not and ghosts. No ghosts. There's nothing to do with ghosts. It just has, so it exists in the realm of random statistics, the realm of noise that could come from just about anywhere. Specifically noise, though, in the 433 megahertz realm and the half frequency and the quarter frequency of that. That's it. That's all it is. It was cool, though. I've learned a new type of transistor amplifier. That would be this guy right here. What was that called again? Let's hold on. Is that one? Okay, like my mouth does not move in the right directions in order for me to say this. A sickly pair. A sizzly pair. Which I don't know if we have too many of those. Because we've got like a resistor there. I don't know. Maybe something else is going on here. Because it seems like they're not really connected to one another. This one might be a sizzly pair. That's somebody's name. It's not Google translatable. Like it's called sickly. Yeah, it's sickly pair is probably the better way to refer to it. But it's weird because like 9 volt, and then we got a pull-up resistor there. I guess they talked about that later on, didn't they? Okay, maybe not there. I think I remember reading that they sometimes have something here, but alrighty. Chat, thank you very much. This has been a short stream. I don't mean for it to be short. The resistors adjust the bias, so they probably biased it within an inch of its life in order to make it as sensitive as possible. Okay. That's going to close off part 3, parentheses, final, of the ghost hunting tool. The 433 megahertz and magnetic field detector. Basically, you get a very quiet signal in, you amplify it a lot, and then you allow it to activate a bar graph depending on how strong it is. You've got stuff to limit the frequency, you've got stuff to stabilize it, you have stuff to make it more or less sensitive, but you're not interested in the content of the signal, you're just interested in how much of that signal is there. So you get away with a lot of crazy stuff in your circuit. Whether or not this could be done cheaper is not really in the purview of it's not in the scope of what we're looking at. But if you just induce a current on that coil, it's enough to get you something out of there. So we know it's sensitive to 433 megahertz based on its length. And then I held my cell phone up to it and sent 123 into Discord. So we know it's not that sensitive to 2.4 gigahertz. But if you get on the right frequency, that antenna is gonna pop off. I mean, the magnet also will affect the coil in a similar manner. And that's it. That's what it is. Those are your ghosts. So as you're wandering around a dilapidated mansion with one of these things, you are looking at one of the most common bands of consumer radio signals present in the environment. Your ghost signal is going to go nuts if somebody, for instance, opens the garage or rings the wireless doorbell that doesn't use Wi-Fi, or if they use their dog's shock collar, or if your camera equipment has any remote functionality to it and looks for the presence of a remote signal. You will see stuff in 433 megahertz, a little bit of the surrounding bands. Ghost comms are 433. Let's get the jammer out. Let's jam the ghost signals so that they can't communicate with one another. Damn it, it's only 3:17. I did start a little bit early. How long have I been going? 3 hours? Are you kidding me? It's like exactly 3 hours right now. Well, thank you everybody for watching. Join the Discord if you want. We had a good number of people watching today. We're going to go back to working on Burn the Subs next stream. That Burn the Subs is this giant log sitting behind me. That giant log on my wall is actually hooked up to an XY table and a blue laser. Speaking of 400 nanometer wavelengths, 400 nanometers, 433 megahertz, 699 millimeters. Man, we're hitting them all today. But yeah, Burn the Subs is basically an automated laser burner what takes the names of subscribers as they subscribe and figures out where on the board they should go, and then commands the machine to use a blue laser to burn it onto a physical piece of wood. I've already run 2 of these boards before with thousands of names on it. We are doing the best effort to make the final version of the XY table edition. The one that comes after that is going to be a radical departure from what this one is. And I got the idea in my head, but we got to finish this one, and we have to do our best job to put it together. Got to work on the power supply a little bit. That's going to involve a little bit of wiring, a little bit of mounting, and a little bit of me giving up all my ambitious goals and deciding it can be good enough. Balbin, hey Balbin, thank you for the 13 months. I really appreciate that. And that's a Prime. So if you guys want to use up those Primes, you got it. If you have an Amazon Prime, you got a free subscription to a channel that you like. So do it, use it up. Do not allow Jeff Bezos to let ghosts into our realm using Amazon Prime subscriptions. You can take it away from him. You can stop him. If you want the circuit, the version of the circuit without my notes on it is in the Discord. You can check that out. I believe it should be pretty accurate to what's there, because our functionality mirrors exactly what the schematic is. So I'm actually pretty happy with that. We knocked this one out of the park way too easily. So in the future, I'm going to keep my ear to the ground for more cool stuff. You guys want to send stuff in, you can catch me on Discord. You can talk to me in PMs. However, I have a policy on viewers sending things into the show. It's that you're basically throwing it away. You're throwing it away, but you're paying the post office to throw it away. I might not feature whatever you send in on the show. I like to take this stuff apart, and I like it to be a one-way street and not, I don't want it to function afterwards, but it all depends on my timing and stuff like that. It's very difficult for me to, you guys send in some weird shit, and it's tough for me to like stop and figure out how to do stuff with that. There was the one index lighthouse that was it was welded together. It was plastic welded together, and I just couldn't do anything with it without completely eviscerating the thing. And I just didn't want to do anything to it. So I feel bad about that one. We still have an oscilloscope that somebody sent in that we need to take a look at. So maybe we'll work on that a little bit. It would be nice to get that functioning, even though it's so old I can't really utilize it in any way, shape, or form. But yeah, that's it. That's it for me. I'm going to end. I'm not going to rate anybody, although we do have, I would love to brag about the amount of people that are viewing me right now. We're not going to raid. You guys check out the channels that you like. I know I constantly promote Davies, who's probably doing My Summer Car or something similar right now. Always talk about Flatulent Gonad. They're friends of the show. Whatever. You guys can, we can turn the oscilloscope into a ghost detector. Let me get my ghost detector out. I mean, that's what they do in like movies and stuff, right? They put all that electrical engineering equipment behind them. We're here for the dog. Damn it. I knew it. Yeah, the Corgi is extremely cute. If you guys are interested in a very cute, fluffy Corgi, and I'm not just calling her fluffy, that's like the type of Corgi that she is. She was hanging out at the beginning of stream. She's locked upstairs right now. I'm going to go say hi to her and end my stream. So I will see you guys later, and I'm back on tomorrow. We'll figure out what we're doing. Probably burn the subs. What button am I? What? No, that's not the, where's the, what the fuck is